ज्ञान से हम सब लाभान्वित होंगे। माननीय कुलपति जी पुष्प भेंट कर हम सब इसमें शामिल हैं, उनका स्वागत करते हुए अंग वस्त्र हमारी भारतीय संस्कृति का बेजोड़ उदाहरण रहा है। हम गुरुजनों को अंग वस्त्र प्रदान करते हैं। विशिष्ट अतिथि के रूप में प्रोफेसर अमित हुसैन गुप्ता जी हमारे मध्य में। कुलपति जी से निवेदन करता हूं कि आपको पुष्प गुच्छ भेंट कर एवं अंग वस्त्र प्रदान कर हम सबकी तरफ से भाव प्रकट करें। प्रोफेसर ए के यादव जी से, हरीश जी से और प्रोफेसर कांति प्रकाश जी से निवेदन है, हमारे श्रेष्ठ नेतृत्व कुलपति जी हमारे चीफ पेट्रन हैं, उनका भी स्वागत पुष्प की गुच्छ भेंट कर करें। प्रोफेसर सुनीता श्रीवास्तव जी भी हमारे मध्य हैं, आपको भी पुष्प गुच्छ भेंट कर स्वागत करें। बहुत बहुत धन्यवाद, अपना स्थान ग्रहण करें। बहुत बहुत धन्यवाद आपका। आइए विषय की थीम के बारे में प्रोफेसर पूजा जी से निवेदन है कि वो मंच को संभाले।
Thank you, Dr. Neeraj. Good morning to all of you. I, Dr. Pooja Yadav, from Department of Microbiology, welcome you all. It brings us great joy to extend a warm welcome to each and every one of you at the National Science Day celebration. Our gathering today is dedicated to commemorating the groundbreaking discovery of the Raman effect by the renowned Indian physicist Sir C.V. Raman, and to honor the essence of scientific exploration and creativity. Throughout history, science has been a driving force behind human progress, inspiring creativity, shaping cultures, and enriching our understanding of the world around us. National Science Day serves as a tribute to the remarkable contribution of scientists to society and underscores the importance of fostering a scientific mindset within our communities. This year's theme for National Science Day is Indigenous Technology for Viksit Bharat, which highlights the crucial role of indigenous technology in adopting self-reliance, innovation and sustainable development. As India aims for progress toward 2047, the emphasis on harnessing indigenous technology becomes increasingly significant, especially highlighted on today's National Science Day. So without any further ado, I request Professor A.K. Yadav.
Honorable Vice Chancellor, Professor Kankeshwar Kumar, Chief Guest, Professor C.P. Kaushik, Guest of Honor, Professor Amitav Sen Gupta, Registrar, Madam Srivastav, and other esteemed guests, Deans, HODs, teacher in charges, faculty, colleagues, prize winners, CUH students, and students from other colleges and schools, and the accompanying staff, ladies and gentlemen. Heartiest greetings and a very good morning to all. It's my great pleasure and privilege to welcome you all to the celebration of National Science Day at the Central University of Haryana, Mahendragarh. We at CUH celebrate National Science Day every year with tremendous zeal and enthusiasm, but this year it is a very special because of the overwhelming response of participants from schools, colleges and universities. We are proudly celebrating National Science Day over last 3 days by organizing a variety of activities and events with enthusiastic participation of students, faculty and staff. Over 220 teams registered for Wonders of Innovation event, nearly 100 teams in quiz competition, 150 entries in speech competition and 80 entries in painting competition. All the events attracted huge participation, especially from schools. The celebrations are culminating today with 2 highly distinguished lectures. National Science Day assumes a special significance for all of us at CUH as we take a pledge on this day to rededicate ourselves to the cause of science and developing scientific temper in the citizens around us. As you all know that National Science Day is celebrated in India to commemorate the discovery of Raman effect on scattering of light by the great Indian physicist and son of the mother India, Sir C.V. Raman, on 28 February 1928. For his discovery, Sir C.V. Raman was awarded the Nobel Prize in 1930 in physics. He was elected a Fellow of the Royal Society early in his career and knighted in 1929. In 1941, he was awarded Franklin Medal. In 1954, he was awarded Bharat Ratna. He was awarded the Lenin Peace Prize in 1957, and postal stamps featuring Raman were issued in 1971 and 2009. This day is celebrated as one of the main science festivals in the country every year, during which schools, students, college and university students participate in a variety of events. It's celebrated to spread a message about the importance of science in daily lives, to display all activities, highlight efforts, achievements in the field of science for human welfare, to discuss issues and implement new technologies for the development of science, to give an opportunity to the scientific-minded citizens of the country, and to encourage people to pursue and popularize science and technology. As it has been announced just now that the theme of this year's National Science Day is Indigenous Technologies for Viksit Bharat. And as students and teachers, it is our responsibility to honor the great man and his invention by greatly contributing to the field of science through dedication, through innovation, through research. And I must tell you very proudly that research and innovation is the hallmark of Central University of Haryana. We are fully committed to this cause and made it our mission. We know Madam Curie, Marie Curie, the great scientist who won Nobel Prize in chemistry as well as physics. According to her, nothing in life is to be feared. It's only to be understood. Now is the time to understand more and that we may fear less. According to another great scientist, philosopher and thinker of recent times, Stephen Hawking, science is not only a disciple of reason, but also one of romance and passion. So it has to reflect the romance and passion also. Today's celebration includes 2 highly distinguished lectures by eminent scholars from prestigious and premier research centers of India. The first one on empowering tomorrow, navigating opportunities and challenges in nuclear science and technology for a sustainable future by Professor Chetan Prakash Kaushik from Bhabha Atomic Research Center, Mumbai. Professor Kaushik, Central University of Haryana, extends a warm welcome to you, and we thank you for accepting our invitation to deliver today's distinguished lecture and sparing your valuable time for enlightening all of us with your rich knowledge and experience. The second distinguished talk will be on Exploring Antarctica, a journey to the white continent by Professor Amitabh Sen Gupta. Professor Sen Gupta, we also extend a warm welcome to you and thank you for sparing your valuable time. We are eagerly looking forward to listening to you on such an important topic, and this is one of the most exciting, most fascinating talks I have ever attended. I have been lucky to have attended this talk in the past also, so I look forward to it again today. I have great pleasure in extending a hearty welcome to all the participants, students, teachers and other guests on the National Science Day celebration. We are indeed lucky to have a visionary leadership in the university who provide not only on an excellent support and guidance, but also encourage us continuously to work towards scientific excellence. We are highly grateful to our Honorable Vice Chancellor, Professor Trankeshwar Kumar, Chief Patron of the National Science Day celebrations, for inspiring and motivating us continuously. On this day, we rededicate ourselves with renewed vigor to continue our pursuit of science for the benefit of humankind, work sincerely towards preserving our mother nature. Let's take a collective pledge to rekindle the spirit of scientific inquiry in our quest for scientific solutions to the problem that the humanity is facing today. I'm fortunate to have a highly dedicated team with me of faculty, students and staff to carry out these objectives. Our talented and motivated students are our assets, and they have been bringing laurels at various national and international levels, winning prizes and awards. Ours is a research and innovation-driven university, and CUH is actively engaged in carrying out and guiding research in thrust areas of science and technology, publishing in high-impact journals and filing patents. Our students and faculty are working on several hundred projects, including the prestigious DST FIST project, which this year we got in mathematics, in physics, and in environmental sciences. Last year we got in chemical sciences, and prior to that we got in biological sciences. So let me conclude by saying that with our well-coordinated and sustained efforts, we are marching ahead on path of success in all our endeavors. Thank you. Jai Hind, Jai Bharat.
Thanks, Professor Yadav. Now I request our highly respected and esteemed Vice Chancellor, Sir, Professor Trankeshwar Kumar, for his address.
Thank you very much. I'm very happy to see students from different parts of the, I will say, state. I could see yesterday the presence of other districts of Haryana, and today I expect them to be here. They must have, maybe winner in some events or not. So I'm very happy that students from the colleges and the schools are present at this small auditorium. And this is a day when we celebrate this as a Science Day. And today we have C.P. Kaushik from BARC, Baba Atomic Research Center, Amitya Sen Gupta ji. I hope you will listen to him, you will realize what kind of association he had. So I am really thankful to today's chief guest and the speaker, Kaushik ji and Amitya Sen Gupta ji. Well, we organized this event for 2 days, and with the participation of the students from the colleges and schools, they showcase their, whatever, they want to, they have learned from the science, school science, and otherwise, they have lot of information available with them through the whatever devices they have in their home or hands. So if we look at the theme of this Science Day is indigenous technologies for Viksit Bharat. We started dreaming about the Viksit Bharat, developed nation. We are considered a third world countries. We are underdeveloped countries considered as, right? So, when we think that, कि भारत में ऐसा हम कहें कि 2047 तक हम विकसित होंगे, बड़ी वो अजीब सी बात लगती है जब हम देखते हैं कि हमारे पास हिस्ट्री में हमारे पास इतना कुछ था और हम इतना कुछ हमारे पास होते हुए भी हम सोने की चिड़िया कहलाते थे। हमारे पास इकोनॉमी जो है इतनी हमारी स्ट्रॉन्ग होती थी, फिर हम पिछड़ गए, कहाँ गए, ये सब आप लोग जानने की कोशिश करते हैं। लेकिन जब हम अभी बात कर रहे हैं साइंस डे की, तो साइंस डे में जो इसका सपना है कि वो इंडिजीनियस टेक्नोलॉजी है, ठीक है, पूरा साइंस डे है, ठीक है। साइंस का इसका मतलब ये नहीं है कि साइंस का हमें जिसे कहते हैं कि अवेयरनेस, पहले हम बहुत सारे प्रोग्राम करते थे कि बच्चों में हमारे साइंस की अवेयरनेस हो, तो अवेयरनेस से काम नहीं बनेगा। पहली बात इन शब्दों में आप देखिए, जो वर्ड है इंडिजीनियस टेक्नोलॉजी, तो अवेयरनेस से काम नहीं बनेगा। आप कुछ जानते हैं और जो इससे जो है आपको कुछ पता चलता है, उससे अपने आप को कुछ कर लेते हैं, उससे काम नहीं बनेगा, ठीक है। तो आपको साइंस को यूज करना है। जब आप साइंस को यूज करते हैं और इसी को हम टेक्नोलॉजी में बदल देते हैं, लेकिन टेक्नोलॉजी जब कोई चीज होती है, विकसित होते ही कुछ किसी चीज की डेवलपमेंट होती है, कोई इंस्ट्रूमेंट बनता है, कोई डिवाइस बनती है, उसमें साइंस तो लगती है, ठीक है। तो आपको जो है साइंस की एप्लीकेशन की तरफ देखना है। दिस इज व्हाट वी टुडे वी लुक एट दिस साइंस डे थीम इज, राइट। सो इफ वी लुक एट फॉर द इनोवेशन, तभी हम जो है आगे बढ़ पाएंगे। और इनोवेशन में yesterday I want to share with my colleagues also, and the students also. Yesterday our education minister and the IIT Madras launched Swayam Plus. Right? It is a Swayam Plus. Swayam Plus is a platform जहाँ पर ऑनलाइन आप पढ़ सकते हैं, ठीक है। आप ऑनलाइन जो है स्वयं प्लस में आप स्किल भी पढ़ सकते हैं, इंजीनियरिंग भी पढ़ सकते हैं, टेक्नोलॉजी भी पढ़ सकते हैं। इट इज ए प्लेटफॉर्म वेल विद द हेल्प ऑफ द इंडस्ट्रीज। तो इंडस्ट्री के साथ मिलकर आप जो है स्वयं प्लस बना है, तो इससे जो है आप टेक्नोलॉजी और स्किल भी पढ़ सकते हैं। सो इनोवेशन जो है, उन्होंने ही कल बताया कि एक बच्चे ने एक जैसे कहते हैं ना कि बॉडी में लेजर स्टिचिंग का कोई अंदर जो कुछ टूट गया है उस बॉडी में आपकी, उसे जोड़ने के लिए स्टिचिंग करनी है, तो लेजर स्टिचिंग जो है किसी ने बनाया है, किसी बच्चे ने बनाया है, ठीक है। उसको अंग्रेजी नहीं आती, उसे अंग्रेजी भी नहीं आती, हिंदी भी नहीं आती, लेकिन उसने बनाया है। इंस्ट्रूमेंट इज इट। तो कहने का मतलब ये है कि जो इनोवेशन जो है वो आपके दिमाग से आती है, आपके आजमाइश का आइडिया है, उसे आप कैसे उसको इस्तेमाल करते हैं, वो किसी भाषा से जुड़ी हुई नहीं है। तो अपने आप को यदि आपको जो समझते हैं कि आपको ये भाषा नहीं आती, तो आप अंग्रेजी नहीं जानते हैं, तो आप इनोवेट नहीं कर सकते, ऐसा नहीं है। केवल 7% लोग हैं हिंदुस्तान में जो इंग्लिश जानते हैं। तो अपने आप को जो है सोचने की जो तरफ है, इनोवेशन की तरफ बढ़िए, राइट। कैसे जो है, तभी जो थीम रखा है इंडिजीनियस टेक्नोलॉजीज फॉर विकसित भारत। कोई भी कंट्री आप देखेंगे वो विकसित नहीं होती है जब तक वहाँ का इनोवेशन जो है, वहाँ के सिटीजन जो है इनोवेट नहीं करते हैं, ठीक है। कहा कि जो कंट्री इनोवेट नहीं करते हैं वो खत्म हो जाते हैं, स्टेगनेट हो जाते हैं, ठीक है। तो वो इनोवेशन जो है वो जरूरी है। तो आप जो विद्यार्थी जो है अपना कुछ ना कुछ नया सोचने की, नया कुछ डेवलप करने की सोचनी चाहिए। इनोवेशन जो है कंट्री में आप देख लीजिए, ऐसी होती है वो पूरी कंट्री को चला देती है। इनोवेशन लगता है कि कॉस्टली है, इट डज नॉट कॉस्ट एनीथिंग, ठीक है। कहीं इनोवेशन जो है वो आपको पूरी कंट्री की इकोनॉमी को चला सकती है। यदि आप कुछ ऐसा इनोवेट कर दें तो पूरे वर्ल्ड में बिके। आपका मोबाइल जो है हाथ में है, सारे पूरे वर्ल्ड में बिक रहा है। पहले तो एक ही कंपनी का आज भारत जो है इतने ज़्यादा मोबाइल जो है बाहर बनाकर बाहर बेच रहा है। तो सब जो चीज़ें जो है मैं कहता हूँ कि अब हमें एज ए स्टूडेंट जो है हमें ये देखना है कि हम कैसे अपना रोल जो है विकसित भारत की तरफ ले जा सकते हैं। विकसित भारत में यदि आपको करना है तो आपको सोचना पड़ेगा, सोचने में अपनी भाषा में सोचेंगे तो ही आप इनोवेट कर पाएंगे। मैं तो ये भी कहता हूँ साइंस जो है केवल अपनी भाषा में ही हो सकती है, किसी ने ये भी कहा है। तो इसलिए ये जरूरी है कि हम जो है इनोवेट करें, नहीं तो क्या होगा, दूसरे की भाषा में दूसरे की चीजें पढ़ेंगे, उनके लिए कुछ करेंगे, उनके लिए काम करें, अपना तो पढ़ नहीं पाएंगे, हमें क्या करना है, हमारी जरूरत है। इसलिए ये बहुत महत्वपूर्ण है कि हम सभी लोग जो है अपनी जो हम साइंस डे मना रहे हैं उस साइंस डे को हमें ये साइंस को कैसे यूज करना है इनोवेशन में, इंडिजीनियस टेक्नोलॉजी जिसे कहते हैं उसके लिए आगे कैसे बढ़ना है, तभी हम भारत को विकसित बना पाएंगे। अदरवाइज मैं नहीं सोचता कि हम दूसरों से कुछ लेकर कुछ अपने आप को विकसित कर पाएंगे। ऐसा हमारे पास कुछ नहीं है कि यदि हम दूसरों से कुछ खरीद कर अपने आप को विकसित कर पाएंगे। हमें अपने आप को विकसित करना है तो हमें अपनी इंडिजीनियस जो है टेक्नोलॉजी लानी पड़ेगी। अपने विद्यार्थियों को इस तरह काबिल बनाना पड़ेगा, वे कुछ ना कुछ जो है नया कुछ सोच सके, इनोवेट कर सके। इसी तरफ जो है हमारी जो 2 दिन की जो है हमारी तरफ से सेंट्रल यूनिवर्सिटी ऑफ हरियाणा की तरफ से ये हम चाहते हैं कि हमारे विद्यार्थी जो है वो अवेयर तो हुई ही, इसके साथ ये भी सोचे कि कैसे वो इनोवेट करके कल को कुछ नया प्रोडक्ट बना सकते हैं, कुछ एंटरप्रेन्योर बन सकते हैं, कुछ अपनी समस्याओं को जो है जो भारत की जो आसपास की सही छोटी छोटी ही सही उनको सॉल्व कर सकते हैं, तभी हम आगे बढ़ पाएंगे। मैं इन शब्दों के साथ हमारे जो साइंस डे को इसको सेलिब्रेट करने के लिए हमारी जो टीम है, प्रोफेसर A.K. यादव है, गुप्ता जी है, ईमान जी है, हरीश जी हैं, और सभी का मैं बहुत बहुत उनकी पूरी टीम को बहुत बहुत धन्यवाद करता हूँ। और जो हमारे विद्यार्थी जो है डिफरेंट स्कूल से आए हैं, जो स्कूल से टीचर्स हैं, और जो भी इस 2 दिन के कार्यक्रम से जुड़े हैं उनका भी धन्यवाद करता हूँ। मैं उम्मीद करता हूँ कि जो इस 2 दिन की जो मैं कहूँगा लर्निंग है वो हो सकता है किसी के लिए अर्निंग भी बने। तो मैं इन शब्दों के साथ आपका सबका बहुत बहुत धन्यवाद करता हूँ। जय हिंद, जय भारत।
Thank you so much, sir. Now I request Professor Kanti Prakash Sharma to introduce our chief guest.
सभागार में उपस्थित अतिथि महोदय एवं आदरणीय श्रोतागण, आप सभी को सादर नमस्कार एवं आज के इस शुभ अवसर पर राष्ट्रीय विज्ञान दिवस पर आप सभी को बहुत बहुत बधाई। राष्ट्रीय विज्ञान दिवस के इस अवसर पर मुझे आज के अपने इस समारोह में मुख्य अतिथि प्रोफेसर चेतन प्रकाश कौशिक जी का परिचय प्रस्तुत करने के लिए कहा गया है, परंतु उससे पहले कुछ शब्दों के माध्यम से अपना जो विज्ञान है उस विज्ञान से आपको जोड़ने की कोशिश करता हूं। देखिए, हम जानते हैं कि आज हम राष्ट्रीय विज्ञान दिवस मना रहे हैं, और राष्ट्रीय विज्ञान दिवस हम क्यों मनाते हैं? हम जानते हैं कि रमन इफेक्ट, रमन प्रभाव, वो रमन प्रभाव आप क्या है? वो एक तरह से प्रकाश के प्रकीर्णन, जिसको आप स्कैटरिंग के नाम से जानते हैं, वो प्रकाश जो हमें चेतना का अनुभव कराता है, वो चेतना जो अजर है, अमिट है। और आज ये मात्र संयोग ही है, हमारे मध्य इस सभागार में कुछ ऐसे शब्द जो कि शब्द में विज्ञान निहित है, जैसे शब्द चेतन, दूसरा शब्द प्रकाश, तीसरा शब्द अमित्व। इन 3 शब्दों की उपस्थिति, और इस उपस्थिति के माध्यम से वो चेतना, वो विज्ञान जो हमारी इंडिजिनस टेक्नोलॉजी फॉर विकसित भारत, हमारा अपना विज्ञान जो हमें अपने भारत को विकसित राष्ट्र की तरफ ले जाने में हमारा आधार है और हमें हमें इस संकल्प की ओर लेके जाता है। तो इस विज्ञान के माध्यम से मैं आपसे निवेदन करता हूं कि जो भारतीय संस्कृति है उस संस्कृति में निहित विज्ञान को समझे और उस विज्ञान को समझकर हम अपने राष्ट्र को एक विकसित राष्ट्र बनाने का संकल्प लें। प्रोफेसर चेतन प्रकाश कौशिक जी आज हमारे मध्य एक मुख्य अतिथि के तौर पे हैं। उनका संबंध अपने इस प्रांत हरियाणा से बहुत पुराना है। वर्तमान में वो रेवाड़ी जिला के रहने वाले हैं। रेवाड़ी जिला पहले जिला महेंद्रगढ़ का ही एक भाग था। प्रोफेसर कौशिक completed his early education from the college of Rewari, and then he completed his post-graduation in chemistry from MD University Rohtak. After completing post-graduation in chemistry, then he completed MPhil from the Kurukshetra University, and then he joined Baba Atomic Research Center in 1985. In the Nuclear Science and Technology Division, and he served lastly as a director for this Waste Management Division from 2017 to 2022. He was also awarded the Doctor of Philosophy from the Mumbai University for his notable work on the glass chemistry for nuclear waste management. As Director of Nuclear Recycle Group, Baba Atomic Research Center, Professor Koushik was responsible for multidisciplinary program for research and development in the field of back end of nuclear fuel cycle. He was also responsible for operation of various back end fuel facilities of BARC, Trombay. He has played a pivotal role in development, demonstration, deployment of innovative technology for separation of radioactive components from waste for societal benefits, thereby making radioactive waste as wealth. Professor Koushik has contributed significantly in various international committees such as member of Waste Safety Standard Committees as well as consultant of Technical Group for Nuclear Fuel Cycle Options of International Atomic Energy Agency, Vienna, Austria. He has delivered lectures in the field of back-end nuclear fuel cycle representing India at several countries like Austria, Singapore, France, China, etc. He is also a faculty member of World Nuclear University, UK. He has several awards to his credit such as Indian Nuclear Society Gold Medal Award and a number of group achievement awards, prestigious Homi Bhabha Science Technology Award. Professor Koushik is also a recipient of prestigious Haryana Vigyan Ratna Award in the year 2022. He is also associated with Homi Bhabha National Institute as a senior professor. He has more than 250 publications to his credit in peer-reviewed international journals. Presently, he is recipient of Raja Ramanna R&D activities, the fellowship of Department of Atomic Energy for actively engrossed in advisory role for planning and execution of research and development activities pertaining to back end of nuclear fuel cycle, including its vitrification. In view of his outstanding contribution, Professor Koushik was also conferred with the title of Fellow of National Academy of Engineering by Indian National Academy of Engineering in 2023. With this short introduction, I would like to request Professor Koushik to please come on the dais for the lecture. Professor Koushik, please.
Namaskar, Suprabhat, and very good morning to one and all of you. Professor Kankesh Kumar ji, Honorable Vice Chancellor, Professor Amit Sen Gupta ji, guest of honor for today's function, senior faculty members, researchers, my dear students. No, I will call my dear young scientists. Ladies and gentlemen, a hearty congratulations to one and all on the occasion of National Science Day 2024. Indeed, it is a prolific honor for me to be here and stand in front of you all on the auspicious occasion of National Science Day. As indicated, this day not only we commemorate for the remarkable legacy of Sir Chandrasekhara Venkata Ramanji. At the same time, we celebrate this day for the relentless pursuit of knowledge, innovation, and discovery, which defines the essence of science. Today, as we reflect on the wonders of science and its transformative power, let us reaffirm our commitment to push the boundaries of knowledge, interdisciplinary collaboration, and inspiring our young scientists to embark their journey on the scientific path in their respective endeavors. So, dear students, let us march together on the firm footing, armed with inquiry of curiosity and strong conviction of science, that through science we can transform the future of one and all to make Bharat a Viksit Bharat. So before I move on to today's my talk, I will, with gratitude and I really thank our Honorable Vice Chancellor for giving me an opportunity to be amongst you on this important day. In fact, this has to be a festival. You remember in Bombay, in Maharashtra, there is a Ganesh Utsav, and that goes for 8 to 10 days. And almost for all the quarters, maybe somebody from students to all the corners, and they celebrate almost with the way we celebrate maybe something like Diwali here. And during celebrations, all of us we enjoy. And look at the scenario. अरे आज तो next period तो physics का है, and then that 1 hour or 40 minutes almost becomes virtually equivalent to maybe 1.5 hours to 2 hours, because they are not able to celebrate. So we need to have that. Okay, this is a festival, and unless and until we celebrate and the subject becomes a burden, maybe out of box thinking becomes to a difficult situation. So when we look at the picture of a movie, 2-3 घंटा कब पास होता है मालूम पड़ता ही नहीं, वो लगता है अभी चालू हुआ था और ये 2 घंटा चला गया. बट 2 घंटा पीरियड में या 2 घंटा अगर घर पढ़ते हैं वो लगता है बहुत देर से पढ़ रहा हूँ. Let us take some break, maybe take some mobile or something like that. But relatively the time is same. 2 hours in movie theater also, and 2 hours at home also for studies. But that 2 hour study somehow equivalent to becomes maybe 4 or 5 hours. So that needs to be changed, and that change can only happen. Maybe last week I was attending one ISKCON, the ISKCON's one gentleman, he did some IITs from Tech and then MBA from IIM, and he was telling maybe to a group of, he was telling about Lord Krishna. Something he asked, "Hey, Bhagwan Krishna ki Bhuaji ka naam kya tha?" and something like that. And almost all of us were spellbound. It was a mixture of good, maybe some 30-40 crowd with a mix. Some are senior, some are young and all. Then suddenly out of the box he thought, "Arey, Kareena Kapoor ki saas ka naam kya hai? Arey, so many people, arey, Frana. Look, immediately there was an overwhelming response. That is what he told. That is what I was trying to tell. So we had to change our color of thought pattern. And then when the day becomes a festival, I am very sure out of box thinking will become, a swabhavik cheez ban jayegi, and then we can always look forward that through science we will be able to transform our country into a Bharat. With these words, I will move on for today's presentation. May I request for? Okay, I can do from here itself. Today's topic of my talk is anyway indicated. So, to start with, I am a firm believer of Vasudeva Kutumbakam. One is a single family. One is a single family. And once we relate each other with the family, there is a question that we must ensure that our extended family members, we worship, we should be all right, we should have a good health and all. So our Upanishads have some good mantras, and one of them is Sarve Bhavantu Sukhina, Sarve Santu Niramaya, Sarve Bhadrani Pashyantu Ma Kashchit Dukha Bhave. With this sincere prayer, I wish that all of you, not only here, but all of us, the Almighty shines His blessings to make us healthy. And it's very important because a healthy body has a healthy mind, and then only we'll be able to pursue our efforts for bringing a high quality of research. And today's research becomes a technology for tomorrow. So a good science and research, we need to have a sound body. So after praying the Almighty for well-being of all, I will go through the course of my presentation, and through the journey of today's talk, I will be taking a halt of on following stations. The way the train starts and stops at different stations, accordingly I will also be taking a halt on these stations. Maybe how we are, I'm talking about the last, how we are viewed internationally. भाई जब तक वो गोली चमड़ी का स्टैंड ना लगे ना, जब तक कोई मजा नहीं है. Remember in our high school days, some boys will come with a watch. अरे मेरा चाचा गया था, ना इंग्लैंड का, this is important. And हम सब लोग तो वो भीड़ लगा के खड़े, and suddenly it's a quite important person. Look, the way we were assigning the things, our affection and love, something to very important, your important materials. And a long back, I went to IAEA, that is International Atomic Energy Agency, Vienna. And that time, almost all of us in India, we were using that what is called floppy drive. And that representative from China was having pen drive. And pen drive, many of us saw for the first time. And they would look at, what is this? No, this is pen drive, it's from China. So the way, the pride he was taking, I really felt envy of this. So those countries who are Viksit or who are advanced, I'm sure they must have done all. And even look at the Chinese and all, even if they go to the highest of even Oxford institutes and all, but they do come back and try to make the same, or you can say very valuable contribution to the country they belong. So how we are viewed internationally, particularly with respect to the work which being done. I will be sharing at whatever work we have done at our Atomic Research Center, and last decade work has really took us on the driver's seat globally in the area of nuclear science and technology. Now, if this is a visualization, if you look at the Mother Earth from maybe space station and all that, you will find that some areas of the Earth, they are glowing more compared to others. What I am trying to tell, that if you look at per person consumption of electricity in a year, per capita, that how much money, but here I am telling per person consumption of electricity. And make sure this consumption of electricity is directly related to quality of life with us, because you cannot envisage any activity whatsoever without the application of electricity. Even my mode of communication to you, if electricity would have not been there, would have been not that easy the way I am talking to you. From that point of view, and I'm sure I'm talking to a students of science. So 1 kilowatt hour is 1 unit. So if you look at the world average, it is something around 3026 kilowatt hour a year per person consumption. And if you talk about US and all, they go even more than 10,000. And look at the figure of our country, that shows something around maybe 1,255. That shows that maybe a lot of work need to be done to bridge the gap. And we know that electricity is directly in relation with respect to the development index. And how do we measure development index? I will come to the next, before how do we measure development index, probably I will come to the next slide. And a gross how this electricity in India presently is coming. Maybe we have all the partners, the stakeholders, the great stakeholder is, all of us are aware that coal, although there has been a now sensitive approach by not only the scientific community but our policy makers as well, that we need to reduce the carbon footprints. That's how in 18 we were around 61% of contribution, and now we have come down to 53.6. Maybe it is not good enough, but we have made a beginning, no doubt about it. Similarly, if you look at the renewable, in 18 there was around 13%, and we have made a good beginning. Our policymakers, they have been putting a lot of efforts on this. There are challenges, no doubt about, but clearly indicates that carbon footprints has gone beyond the desk of scientific community. It has really gone to the policymakers. That means the effect of carbon footprints in terms of global warming has is not only been limited in papers, publishing papers. Rather, nature has started showing the signature of global warming. So presently, we don't have any other alternative but go for what is called energy mix. Now, the quality of life, I was trying to, there has to be some measure, no? How do we measure? There has to be some scale, and the scale is called presently, one of the scale is GDP, that is gross domestic product. How we define, many of us may be knowing, but nevertheless, just for the sake of simplicity, this is a monetary value. Like if I talk about in a case of our country, the monetary value of India, which we achieve through production as well as services in a specific time. Now, this I am trying to relate with the consumption of electricity. Present our production of electricity is 416 gigawatt electric from all the possible ways, including coal, including nuclear, including hydro or renewable, put together. And if you look at how the energy requirement will increase with the passage of time, and just I have mentioned in 2030, maybe another 10 years, now presently 24, and maybe 8 to 10 years, and if you look at a modest growth of around 8% of GDP, then also we'll be needing something around 800 gigawatt electricity of power. Presently we are at 416. That means something need to be done at a war footing. And that too also with a nearly zero carbon footprint, so that from 416 gigawatt electric we can go to 800 giga electric if we have to think that from Vikashsheel Bharat to Viksit Bharat, if we have to transform, this is another important area which we have to do within a given time frame. Probably this was the essence of this particular slide. And now, if we continue to bank on coal, a calculation shows something around 3 to 4 billion tons of carbon dioxide will be pumped into the atmosphere. And I'm sure this scientific gathering of students are aware the seriousness of having carbon dioxide getting pumped into the atmosphere. So we look for solar, we have a nuclear, then we have a coal. These are presently the three major partners. And if we look at a simple comparison, in terms of capacity factor, we call as a wind, solar, and how we define capacity factor is electricity produced divided by maximum installed capacity. So the capacity factor wise, we look at nuclear almost counts to 90% in comparison to 20 and 25%. And as I was telling, the global warming is now no more is a subject of research. Rather, it has gone into a domain where nature has started its signature. So it is not only it's real now. Earlier, maybe 20 years before, we were just making some paper and publishing into a good high impact journal. But now those either has gone. Things have started showing the effect. Look at the part. If you see since 1880, average global temperature has increased by 1 degree Celsius. And if we continue the same way, probably up to 2050, that will have 1.5 degrees Celsius increase in the global temperature. And this particular curve also shows that almost from 1900 onwards, there has been if you look at the slope of the curve, there has been a rise, sharp rise, indicating that from the onset of our industrial revolution, there has been a sharp rise in CO2 or the temperature rise, because both are correlated with each other. And the effect, the consequence of rise in global temperature, I'm sure all will be able to appreciate that this will result in melting of ice, which will be resulting into rise of sea level, and the coastal city will be one of the target threat to start with. Now, if you look at the Earth atmosphere, very simple slide, maybe all of you will know it, but for the sake of simplicity of the continuity of this presentation, see, almost more than 99% of our air composition is almost not having any problem whatsoever. Talk about O2, N2. But the greenhouse gases, which is less than 1%, is almost dominating the show, because particularly you talk about CO2, the main player to play an important role in the global warming, and the reason being is very closely related to our science. Yeah. Again, in 10th or 12th class, I was thinking why we are studying this change in dipole moment and absorbing IR radiations and all. Why at all we are studying? Whether we have any consequences whatsoever in daily life? Probably that time we were not knowing. Anyway, the gentleman faculty member is teaching, and we have to mug it up and somehow omit into our exams and throw some maths so that we do some maybe competition here and there and get a job to earn better. We were not understanding the seriousness. And presently now one we understand, because presently I happen to be a student of science as well as a practitioner of science also. Because a good scientist has to be learner all the time. It's evolving. Science is evolving, all the time. So now we look at even the small concentration of CO2, how much effect it can have on the environment. So presently, almost when we talk about before industrial revolution, the average concentration was around in the atmosphere globally were around 200 ppm, and today it has gone to around 400 ppm, and that change has really made to absorb the IR radiation coming from the cosmic rays, and that IR absorbs, and while reflecting also it absorbs. That means that ultimately is the main reason for having warming of the earth. Maybe you can have other non-green gas also, maybe methane, water vapors and all, but their role or their contribution is relatively very, very less. That's how the whole world is crying how to reduce the carbon footprints. So look at the nowadays news, floods in North India, Typhoon Lanka in China, hurricane in United States, floods in China. There have been ample examples. My aim to slow this slide was that this has gone beyond the domain of a scientific community where one can have publication in 2, 3 in some good impact journal, maybe around 5 or so, and then have a good publication. But now things are going beyond that, and we need to do something on the war footing basis. Now a question comes, what we mean by the nuclear. When it comes, the word is uttered nuclear, maybe many of us, because of our ignorance. And that ignorance can be there with the highest intellectual person also. And the reason is not unjustified, because if you look at the nuclear fission, invention was in 1939. And not many inventories, you can count, even if you find one, I would really appreciate. Not many inventions will have been there where the first use has gone for a destructive purpose. And that destructive purpose had a very strong impact on the individual's mind. And that's how, whenever we look about word nuclear, invariably, normally we think that way. But the reality is entirely different. This is because of our ignorance, because the first use happened, not many discoveries are there. And if you look at the nuclear technology is now benefiting the society at large in almost all the fields. Electricity, you talk about health. I'm sure health, many of you will be knowing, you have a radiation therapy for diagnosis as well as for treatment. Food irradiations is playing very important role. And many of you will be knowing that mangoes, like other fruits also, are being exported to other countries, maybe US and all, and they go with they mix US with and they go with the world WHO practices that whenever from here we send, and many of things were getting ripened and all, and our farmers were not able to get the desired profit. How much effort they were putting, it was not getting proportional benefit of it. So the food irradiation also helps immensely, and presenting the today's practice is after getting all the regulatory clearance from not only Indian government as well as from US as well as from WHO, and now they are being shipped. They are being shipped they are going through sea, which takes around 30 days or so without any ripening part and any loss. More important, any loss of neutrality. So presently, national security anyway, all of us know that nuclear energy is a deterrent from security point of view, and technology, I will be taking examples of many slides, and of course it plays a very important role in other industrial development. We talk about petroleum industries. The pipelines through CNG they go from kilometers. How to check the integrity of those pipelines? There is what is called radiographic quality testing. They check, they put some radioisotope, and above the pipe they count with the counters whether the integrity of the pipeline is up to the mark or not, because one be aware that very inflammable gas and all will be flowing through this, which will a small spark is loud enough to create a lot of problems. All of us, we know that this is when we talk about nuclear energy, it is equal to mainly E is equal to mc square, which clearly indicates mass and energy are interconverted, right? And if you look at the energy content depending on the mass defect, just to appreciate the example, if you took at the two typical bundles of maybe 27 kg of uranium, that energy which will be coming out from there because of the fission process will be equivalent to as high as 700 tons of burning the coal, and you can estimate the amount of CO2 which will be getting pumped by burning that much amount of coal into it. And as by our comparer has mentioned very correctly, that not many your scientists have got probably, I don't remember even about nothing less than Madame Curie, who have got Nobel Prize in both the subjects of physics and chemistry. So really, that means clearly indicates the woman power is also equally for the sustainable development of the nation as such. So I'm now trying to introduce to the nuclear subject to all of you. We define mainly one as a fissile material, one we call as a fertile material. The fissile material is one which directly undergoes through the process of fission, and with thermal neutrons, energy is quite less there, thermal neutrons. And the fertile material, their fission cross-section, I'm sure my students or my young scientists from physics, they will be understanding the word cross-section. That indicates the reactive probability of having the reaction from that. So the fertile material will not undergo, or the nuclear fission cross-section with thermal neutron is too less. So but they are not silent. They interact with neutron and what is called neutron activation, and the fertile material gets transformed to a fissile material. That's called, when we say uranium has got many isotopes, and when we talk about natural uranium, uranium-235 is the important fissile material. Similarly, plutonium-239 is fissile material. And our country is not having a good reserves of uranium. We heavily bank on the importing of uranium from other countries, but nature has compensated us with a good reserves. World 1/3 reserve with thorium. So thorium is a fertile material, again with neutrons it goes to 33. And another physicist, Fermi, his hypothesis, is one of the quote I have taken. If whatever experiments we do, if the result confirms the hypothesis, that means you have made a correct measure. And if the result is contrary to the hypothesis, that means you have made a discovery. What he is trying to tell, as our Honorable VC Saab was telling in his address, that any setback is opening the door of opportunities. So in experiments, in researchers, a setback rather is a door which is offering other opportunities. And coming to Indian context, the father of Indian nuclear program is Dr. Homi Jahandir Bhabha. Again, he could foresee that time, way back almost in 1950s, that nuclear energy in a country like India will have an important role to play in healthcare, food and water, electricity, cutting-edge science and technology, and national security as well. So the first reactor, nuclear reactor I'm talking about, came in 1956, and that time, look at the deal with that time scientists were doing. We were first in Asia. So we were first in Asia in 1956 when we had the first nuclear reactor called our Apsara. And today we know this is a typical picture of Bhabha Atomic Research Center, where we have two reactors. One is called Dhruva, one is Saras. Saras was made, it's a research reactor from Canada's, we call them as a can-do reactor. And Dhruva was with the 100% indigenous technology. It got critical in 1985. When I use critical, I'm sure many of you will be remembering that maybe last week our Honorable Prime Minister where he has gone. Any guess? He has gone to Kakrapara in Gujarat. our Honorable Prime Minister has gone to Kakrapar in Gujarat, where he has given 2 nuclear reactors of 700 megawatt electric to the nation last week itself. So these 2 research reactors is basic science research, radioisotope production. Radioisotopes are being very important for diagnosis as well as for medicines and education and training. Of course, many of the universities they go to these reactors for understanding studying the material behavior by taking neutron iterations and studying the structural alterations also on this. A typical example of a nuclear reactor, there's a core, and then because of fission, the cooling water gets the energy gets converted into high pressure steam, and it is the high pressure steam which in turn rotates the turbine of generator. Is how electricity is produced. But what I'm trying to tell, this is a defense in depth technology. This scientist is looking for the part of defense in depth, what is the multi-barrier concept, which we have been using in a nuclear reactor as a safe operation, and as one of the worker of nuclear technology, I take a pride in sharing. Right from 1956 onwards, as on date, our nuclear reactors are operating in a very safe and safe manner. Now, we have a 3-stage nuclear power program, where the first stage we were using nuclear reactor for what is called pressurized water reactor. Water has got different isotopes. One is water, one is deuterium, and one is called tritium. So deuterium based we call as a pressurized water reactor, and as I mentioned, we are not having good reserves of plutonium. So there 238 isotopes, more than 99%, have picked up and neutron gets converted into plutonium, and 239. So we came to the second stage. We have called fast breeder test reactor. The uniqueness of fast breeder is it produces more fuel than it consumes. That's how the breeding means. So that means this is a very important step in terms of optimal utilization of resources. And third is that we should stand on our own feet. And that is possible when we exploit the use of thorium, which is in good amount in the country. So the fuel cycles, if you look at, the way we use coal in a typical thermal power plant, we use uranium as a fuel, and there are 2 options available worldwide. They put in a nuclear reactor, important reactions goes on, fission reaction, when the fissile atom is interacting, and another is the heavy, non-fertile material again picks up neutron and makes a fissile. So that is done. But there is a one school of thought in the world. They extract the energy, and whatever is left, that will be fission products and all, that will be called as a waste, and that is being presently stored, and they want to dispose it of. It's called open fuel cycle. But India has not gone for open fuel cycle. We have gone for a closed fuel cycle. The spent fuel also is reprocessed. Look at the closed fuel cycle. India leads the table of closed fuel cycle, and there is an open fuel cycle also. Closed fuel cycle means the fuel coming out from reactor, that is called spent fuel, and India leads the table where we say spent fuel is a material of resource, and we reprocess and recover all the useful item, and that gives a birth of what is called circular economy. So nowadays there must be 2 words: linear economy and circular economy. If we have to move forward, we have to make sure the residue of one process, and this is no longer limited to only nuclear, but everywhere the process to be chosen in such a manner the residue of one process should become an input for other. Then only we should be able to recycle and reuse and result into what is called circular economy. So this is what flush fuel goes to reactor, we call spent fuel, and spent fuel we reprocess, we recover the uranium, we recover the plutonium produced in the fission. Plutonium is not a natural material, it is a man-made material. That means there is no sell tag, price tag is not there. Koi dega nahi. And that plutonium can be used or is being used as a fuel for future reactors as well as for strategic materials, as a strategic requirements. As I told you, as a rape and deterrent, nuclear deterrent. and the high level radioactive waste. This is coming because the fission hota hai, kya hoga? Lot of fission products will come. So fission products are radioactive. So those fission products used to be called as a waste, but the work what we have done, for which the nuclear scientific community is now is appreciating and putting us on the driver's seat, that no, the fission product also, they have their own valuable contribution to the society. So these are the typical, if you look at the Indian map, where we have nuclear power plants, and in Haryana also, maybe many of us are aware that near Sirsa we are going to have the already construction work is in progress, and going to have 700 megawatt electric 2 units. The same unit what we have our Honorable Prime Minister has given to the nation in Kakrapara last week. So coming to generation of waste, you cannot name any activity, forget about nuclear timing, any activity where where you will not have any waste. But there has to be a out-of-box thinking that just this waste product also with some process. See, VC Saab has told very nicely that process जानना जरूरी ही नहीं है, बल्कि उसमें you have to go deeper and try to check, is it possible to find something out of box? I will give an example. This is what we call the chemical. This I am trying to difference between the chemical waste and nuclear waste. So chemical waste is hazardous forever, but on the other hand, nuclear waste is not hazardous forever, because the hazard potential gets reduced as a function of time, primarily depending on the half-life of the radioactive material. So this is what I was trying to tell, right from the, even if you look at the human civilization, everywhere and anytime any process is developed, you will have some or the other waste. Important is to need to have an eagle eye. Is it possible to find something useful and contribute to as a part of circular economy? So you have a different operations where the radioactive waste is getting generated. Now you look at the this slide shows that human civilization has been existing in presence of radioisotopes. Even if I have a counter here and the animal's forehead, if we put, it will show some contamination, or radioactive contamination. That is coming from potassium 40. And we हम दूध पीते हैं, then we take fish, whatever material we take will have some other, that the wall what will have also will have a residual content of nucleides. That means human civilization has been existing, coexisting in the form of radiations. And one more very sensitive, very exciting information. Radioactivity to some extent is beneficial for the health. This is the latest you can say paper which I will show, and they help in particularly repair of DNAs and for increasing the immunity part. The recent paper which is published maybe in terms of scientific community in the paper of impact factor more than 10. I have a slide on that later on. So this is what reduce, reuse, recycle, recover, and residual. So residual has to be ideally zero, or it should be as low as practically possible. If we have this type of system, then we can have what is called circular economy. A typical reactor, I'm just trying to compare between the coal thermal plant and a nuclear plant. You look at the amount of residual waste getting generated in a typical coal plants, and as I was telling, that things have gone beyond, it has gone to policymakers, and worldwide there is a conference of parties. There's a very international important meetings where mostly हर एक nation के head जाते हैं. So माननीय प्रधानमंत्री जी also have gone, even latest in 2033, maybe in December 1st, 2023, I'm sorry, 2023, and that was the last latest you can say COP, and all the international players now they are trying to know something needs to be done to reduce the carbon footprint. That means a serious thought has come, and after the Fukushima, Fukushima in 2012 or so, there was an incident at Fukushima, Japan reactor. There was a worldwide decline in the nuclear part, but now when the carbon footprints need to be made as low as particularly zero, then all worldwide also they are rethinking and again going ahead for their nuclear parts. Look at the recycle and reuse is a very important part, and waste management is a very key component. And I'll give a simple example of cigarettes. ये local लड़का है, नोएडा, दिल्ली. I'm sure many of you might have seen in your Google also. These are taken from the Google. In this slide, I don't have any my own contribution, but I'm trying to show that how out of box thinking can help. See, plastic and वो सिगरेट का फिल्टर रहता है, वो हम लोग बड़ी शाम से वो मतलब कभी नाक से कभी कहाँ से मतलब वो और वो that is called cellulose acetate. And that is a non-degradable material. That is a non-degradable material. And all those this your cigarette का देखिए. And plastic का कचरा तो of course it has made a really very serious problem. What we call as a domestic waste. It has really made a very serious problem in Delhi. Maybe there, Gazipur or the height of that part almost going to be very close to Qutub Minar basically. And something needs to be done seriously. And that is possible only when we think out of the box. Just by reading and putting exams and then maybe getting good marks probably will not make an indigenous technology. And let me tell you, Indian problems need Indian solutions. वो कोई गोरी चमड़ी वाला कोई प्रोसेस देने वाला नहीं है बस. We have to work our own, and I'm sure we can, because one of the strong points is we have the fraction of young scientists in the world is maximum in India. So this has been why not cigarette case ko these two gentlemen are from Noida. They have made a startup. And now almost they are telling that I don't claim any authenticity of this because I have taken from Google, but it must be true that the concept is that this out-of-box thinking is able to convert a non-degradable kachra, that into some useful product. And they are telling it is now, they are asking that आप हमको cellulose waste दीजिए. This is one. But another authentic part is जब अपने ये जापान में जो Olympics ना जापान. So उनका जो आपका all medals, practically gold, silver and bronze, they all were recovered from e-waste. E-waste से recover करने के बाद so that was given an excellent example how recycle and reuse can radically or dramatically change the color of thought patterns of an individual. So we see the basic units, how the waste management is done, delay and decay, and near zero discharge. We want to make sure that there should be zero discharge of radioactivity into the environment during O&M, that is operation and maintenance of nuclear facilities in the country. And as I told, nature mein tradition hai. You talk about air cues, NPPs, medicals, and we classify the waste in low-level waste, intermediate, and high-level, primarily depending on the concentration of radioactivity present and half-life. These are two important things. This helps in classification of waste. And the general strategy for waste management is concentrate and contain. Kuch karna nahi, you have to concentrate and contain, allow them to decay. And one fine morning they will become non-active waste because they are decaying to get stability. So high-level waste of today will become a non-radioactive waste for tomorrow, particularly depending on the half-life of materials. So it is a multidisciplinary subject. It talks about separation chemistry, material chemistry, nuclear chemistry, spectroscopy and thermochemistry. Similarly, chemical technology, mechanical engineering, glass technology, robotics, and there is an amalgamation of all the technology for a typical multidisciplinary subject for this. These are the basic steps. We have to do some pre-treatment, but the basic philosophy revolving is that no activity should go into the environment. And now I start about the gaseous waste. आपने देखा होगा your COVID part has really shaken the world at large. A simple, very small size to talk about, and yes, almost as good as we were not having any solution whatsoever. And so mask cover हम बोलते थे maybe M90 or they all were non-degradable, and maybe I don't know how many of you may be knowing. We were all 99% of those materials to make a mask. We were importing it from China. And how they were working in the principle of what is called the electrostatic charge. And that means एक बार वो जो your COVID particle gets attached, that means that is non-reusable and non-degradable as well. And that time also we developed a material which is degradable also, and what was called as a M99, much more efficient in terms of retention, because tomorrow you can have what is called NBC war, nuclear, biological and chemical war. So how to proceed? That means the indigenous technology has to serve our own purpose. Nobody else will give this type of technology to any other countries. So the gaseous waste is retained through a high efficiency filter. There will be a chimney, but before the waste is going to chimney, the high efficiency particulate filter, they retains almost all the radionuclides before the air is getting pumped into the atmosphere after a rigorous checking and monitoring. And these are the solid waste, which because filter में तो एक्टिविटी मरी नहीं है भाई, वो तो filter पे आ गई ना. उस प्रकार के जो waste को we compact and allow to dispose in these facilities. These are all engineered modules which are in the proximity or within the our complex of nuclear facilities, and within a period of 20 or 30 or 50 years they will have activity equivalent to innocuous level. What do you mean by innocuous level is equivalent to natural uranium radioactivity for which human civilization has been existing from ages. So these are again highly chemistry driven process. You know chemical precipitation. What is the principle? Solubility product again. You talk about ion exchange. I'm sure ion exchange is the process all of you are aware. I will just give an example of reverse osmosis. RO. If you go to Chennai, you will find a lot of private factories have come where they are converting seawater into potable water. You know, कल का अखबार आपने देखा नहीं मालूम नहीं. Cape Town, South Africa, they are telling that they have उनको पीने का पानी नहीं है, and राशन में पानी मिलना चालू हो गया. The way we used to take earlier, राशन में चावल और चीनी वगैरह, now they are taking water in this, and maybe they may start telling, अरे जरा once in a week now भाई, मतलब if things does not improve. So कहने को we say we have it because they put the water in sea and all, but what is the concentration of potable water? That is very, very less. So RO is one process by which one can convert sea water into potable at a very, very reasonable price of 80 paisa a liter. In fact, VRC has got several plants, and with the initiative of our Honorable Prime Minister, VRC has also adopted several villages where they are giving this water with the help of this technology. This is again a process for you can say recovery of radionuclides from intermediate level waste. This is what is called bakelite. Have you heard the name bakelite? This is a resorcinol formaldehyde antigen. I'm trying to show this because the chemistry again is playing in the driver's seat for the all development of this technology as well. I will give you an example of physics and don't worry later on. So this is very important material for, this is very selective for ion exchange. And look at how we are playing the ionic radii as well as hydrated ionic radii. You must have heard that ionic radii, if you go from top to bottom, like lithium, sodium, potassium, rubidium, cesium, and the ionic radii and hydrated ionic radii, they are not the same. You know, because of the hydrogen sphere, they will have different. So they are playing a small difference of these properties and then able to develop the indigenous material for treatment of this. This look, see the sodium being this, it is getting replaced. In the bulk also, it is getting replaced. How this is actually resin is helping to recover the radioactive waste, radioactive nuclides from the intermediate level waste. And this is the chemical plant and how this resin, which has been the yellow part, shows in this shielding material, that chemistry developed material was again, we have to work in called development, demonstration, and then deployment. These are the three stages for which one has to pass through with a rigorous testing. This is how high level waste, when I say high level, it means the concentration of radioactivity is very high. So you talk about the fuel, initially we have to chop, dissolve, because we have gone for a closed fuel, dissolve, and then we play with the valencies of plutonium and uranium. I'm sure your MSc, you must be reading the solvent extraction part. So here, again, we are using solvent extraction technique, which is the organic fluid, which is called trimetal phosphate, and this gets preferentially into organic phase depending on the valencies. So we are playing with the valencies of uranium and plutonium, highly chemistry-driven process. Again, chemistry plays on the, and then this is the solvent extraction column. We call it as a pulse column to recover, and then whatever the fission product is called high-level waste, which is posing internationally a serious problem. And India has gone for innovative research and then deployed where the waste material is converted into it. So look at PU&U is recovered and being further used as a strategic material as well as the fuel for future reactors, but there are present products which are being used now for different purposes. Look at the high level based composition. Almost all periodic table is getting represented. Look at the complexity involved in this. And BRC में scientists कहीं वो alien लोग नहीं हैं. All of you are there. See, we represent a combination of all the universities. From university like this, only people come there, and then they do wonders here because the यहाँ के जो those faculty members, I really salute all the faculty members who do a job for us, and they send their representative there, and then they do a very commendable job to earn name and fame on the globally. So this red part shows that these are the components that are present in this. Now look at the if you have to do some separation, annexation and all, you need to understand all the chemical and physical properties, not only across the your horizontal rows, but at your column as well, and with small minute difference, then you have to play and develop the process. So very chemistry, one has to have a gross understanding of chemistry too. A good research, how it culminates into a technology, this is what I was trying to tell. And 3-stage program for management of high level waste, presently it is stored into underground tanks. It is taken to a plant through underground piping, converted into a glass. It's again a physics subject. Glass is it crystalline, or it is a polycrystalline, or it is a amorphous material. So the glass is not a new word as such, and presently glass is a very versatile, almost even 30 to 40% of construction work even we use glass nowadays. And these are the glasses, the special glasses where the radionuclides, they are getting part and parcel of the structure of glass. And why the glass has been chosen, this must come in mind as a curiosity, and this part that again international scientific community has learned from the nature. If you look at the natural glasses, even near Bombay we have a place called Thane. If you look at some survey of geological survey of India, maybe something around 65 million years before, some meteorite might have fallen, and the mother silica and then all they convert into glass. And when we took the samples and found that their glass composition is something similar what we go for our base composition, giving a part that जब का glass बना हुआ अब तक भी it has not degraded noticeably, clearly giving a hint. Look, glass can serve as a host structure, as a host for retaining the radionuclides for a long length of time till they will decay to innocuous level. How the technology, sometimes nature starts giving hint. Nature always wants to help, provided we should have an eyes to see. We should have eagle eyes to look at it. So these are how again 3-dimensional structure of glass. I may not go into details of this because of the time scarcity, and again you have to play with the phase diagram, which is a very important part. Again, maybe physics as well as chemistry, both phase diagrams is very important to find a region where we are able to find the typical glass formulations. And we need to have a detailed product characterization. But here I may just caution you that हमारे पास ये instrument है, हमारे पास वो instrument है, doesn't you need not take a pride. Maybe pride one, that getting a fund from the required agency and procuring is one. But the person sitting behind the machine is more important. Because that is what, how a small difference sexually that I should be able to distinguish. Look, small peak here and was not here and all. Those things need to be done. So only having the instrument alone is not a matter of proud. Rather the person behind the instrument, I really salute that gentleman or to make sure that he's able to understand the language of the instrument and is able to help a teeny difference, a tiny difference between the product properties. And this is a typical plant structure, how the hot cell are being used. When I say hot cell, inside all those robots will be working for you, and you can do all the operations outside because of the thickness of 1.2 meter thick wall will not allow any radiation to come. These are all the technology which are being put in the hot cell. I'm trying to skip because it may need more time to part. But this graph you must look at it, how the waste is becoming apparent. So if you don't remove anything, the waste will become inactive after almost 1 lakh years. A time for which one cannot predict the stability of even geotectonic parts and all that. If you recover the long-lived part, plutonium and uranium, it can come to maybe 1,000 years, 10,000 years. If you remove them also, then it will come to 300 years, because cesium and strontium has a half-life of 30 years. So 10 half-lives are required to minimum go to below inox level. And if you remove them, then really the waste. Not only remove them, remove and deploy them for utilization. That's how a circular economy comes into picture. Again, वो remove तो बोल दिया बड़ा आसान, but remove कैसे करेंगे? If you have to do solvent extraction, do you mean? In fact, Sarah has told in a very simple language, but very important part. I'm telling about on the vice is up that nobody else will give the technology. अरे ये ले लो, और तुम अपना जो भी remove करना remove कर लीजिए. Nobody will do it. You have to develop. This is again typical organic chemistry approach. Calyx crown, these are crown ethers. I'm sure our researchers, our young scientists might have at least had a name. And today, if you need a name for friendship, I'm sure tomorrow we'll know much more about that. So these are the organic compounds which help for recovery of the long-lived person. These are the two plants. And actinide separation is the first plant in the world which India developed the indigenously, developed the molecules organic in a milligram to then kg level, and then utilized and we recovered this part also. Look at the green area, shows the waste, which will be left if you remove all this from the red tower. So if you recycle and use, the waste becomes almost nearly zero. So waste is a wealth. We are recovering cesium also. We are recovering strontium and ruthenium as well. And they are being used for different societal applications. Look at the cesium-137 which we removed and recovered, put into non-dispersible form. And that time, India was the first country in the world where we recovered the cesium-137 and used for blood irradiations. And this was the first part where our chairman Vyasar is there, and for sending to BRIT. BRIT is our Board of Research and Isotope Technology. It's a commercial window for getting these isotopes to all the industries in India and abroad as well. And look at this is a particular typical where that lady is operating. It's a blood irradiator unit, which includes cesium-137, which has been extracted from the waste. And similarly, recently, some maybe 3 to 4 years before, ruthenium-106, another isotope was recovered, and that is being used for treatment of eye cancer. And let me tell you, there's only one country, one company in the world. You can check from Google, Messrs. Bibic, Germany. They were selling this, you can say, ruthenium-106 flakes all over the world for eye cancer treatment. And when we went to AIIMS Delhi, in fact, I came to AIIMS Delhi and talked to the director, they were almost telling that because of import, the load to a common man is going to around 15 lakhs per one eye cancer treatment. And we developed it from VRC and almost, but initially, anything will be resisted. Again, so, is different and all. Then BRC gave some 10 plagues free of cost. And aims to aims. And then we use a different language. So, sir, you tell us कहाँ हमारा gap है, we will improve it further. When we started talking in a different language, but hands up to them as well. Within 1 year, they told, "Arey sir, आप लोगों का product is as good as or even better than what they were importing, and they have stopped importing." And then aims करे, so all other our Sankar Netralaya and all, they have to follow, and they are following now. So today in India, nobody imports from that part, and then the message started coming from other developing countries, Sri Lanka, Bangladesh, and we started getting a message from Germany. अरे तुम हमारा दाल रोटी पे क्यों लात मार रहे हो भाई? क्योंकि वो 15-20 लाख हम लोग we are almost selling, because the benefit of science must go to a common man as such. Look at, this is a particular example of your AIIMS MD, and this is being how his vision is salvaged using ruthenium-106. And again, this is the vision I with the cancer part, and this is the vision almost becomes after the ruthenium-106. It emits beta, and beta energy is, might have read that range is not high. Gamma का range ज़्यादा होता है. So gamma अगर लगाओगे तो it will kill healthy tissues as well. So the ruthenium-106 plague was put, and being the range is less, it killed all the cancerous cell as well, and then it became the vision could be salvaged. It's even in the army hospitals in Delhi, they could salvage the vision of a small boy almost he has not seen a life, and because of eye cancer treatment, thanks to the benefit of science, that we could recover the ruthenium 106 from waste and could be utilized, and then the vision was salvaged. Maybe some 1 minute small.
Bhabha Atomic Research Center, the premier R&D center of DAE, is engaged in developing technologies using radiation for healthcare applications and treatment of cancer. DARC has indigenously developed ruthenium brachytherapy, RUBY, plugs for eye cancer treatment. Ruthenium brachytherapy is being used globally for treatment of eye cancer. In this treatment, a ruthenium plug is placed on top of the tumor. It delivers selective radiation dose to the tumor without damaging the healthy tissues of the eye. This treatment modality is safe and has a very good track record of vision recovery and eye salvage. Ruthenium plug contains ruthenium-106 radioisotope. It is produced in nuclear reactor by fission of uranium-235. This fission byproduct from spent fuel is harvested in its purest form using a series of separation processes. The recovered ruthenium is further electro-deposited on silver disc, which is sealed and formed to produce the ruthenium plug. Ruthenium plugs of round and notched configurations are being produced for the treatment of eye cancers. The notched configuration is suitable for treatment of eye cancers located adjacent to optic nerve. The notched and round plugs are used for treating eye cancer like uveal melanoma, conjunctival lymphoma, ocular surface tumors, retinoblastoma, etc. Complementing the RUBY plugs, DARC has also developed plug simulation software to assist doctors with optimal treatment planning. The software provides an easy-to-use interface for calibration and dose rate distribution of the RUBY plugs. It predicts treatment duration and dose received by other healthy parts of eye. Ruthenium plugs are being used for eye cancer treatment at several hospitals in India, including Center for Sight Hospital, Hyderabad, RE Center, AIMS, Delhi, Sankara Eye Hospital, Bengaluru, RE Hospital, Delhi, Hinduja Hospital, Mumbai, Fortis Hospital, Gurugram, Haryana. More and more hospitals are progressively adopting ruthenium plugs for better and cost-effective treatment of eye cancer. These plugs have gained the trust of the doctors and the patients alike.
The plus engine are very much advanced with the traditionally available
DARC is now developing pediatric plug for treatment of retinoblastoma and crescent moon plug for treatment of cancer near the cornea. Ruthenium plugs are available through Board of Radiation and Isotope Technology. Indigenous development of ruthenium plugs and the plug simulator are major breakthrough in the area of Atmanirbhar healthcare and providing affordable treatment to eye cancer patients in India.
must have seen even the live commentary of our Chandrayaan-3. I don't know how many of you know that this included one of the radioisotopes extracted from radioactivities. I don't know, are you aware why it is required? You know, Rhenium-241 is one of the isotopes which is required for as a heat source. So, you know, it goes and for 15 days when it is not facing the sun, that time temperature becomes too less. And my colleagues from student of physics, they will be knowing better than me that when the temperature becomes negative and all our semi-current device, they become sluggish, and that particularly that decide the usable life of a typical Chandrayaan and all. So this is the Rhenium-241, which was recovered from the waste and converted into a heat source, was given to space. So what I'm trying to again narrate and tell that the benefit of atom, the power of an atom of science is extended right from the healthcare even to the highest technology of space as well. Now the recovery of strontium again is for therapeutic application. Maybe I may go a little faster because maybe I have to get some time as well. So these are the radioactive waste being stored to make sure that heat gets dissipated and then it is disposed. So it is called interim storage facility. And the concept of geological disposal, it has to be disposed once the heat is dissipated, and maybe the depth may be around 50 to 100 meters, and a time will come when they will become no longer radioactive. But now there is no waste to dispose. Everything is now as is used. That's how the waste from wealth has come with no waste at all. Now look at whether the development of technology has got any application for non-nuclear part. This is giving two examples. One is for the municipal solid waste and another is water. You look at this gentleman being a nuclear scientist, you are trying to tell, okay, after developing this, is it having any scope to apply for non-nuclear part? Two examples I will give. This is what I was trying to tell, the Delhi picture of Gazipur, then things are, and you know, you may be aware, this municipal solid waste is having its own calorific value. Hey, kitna hoga? They're all having energy. This is energy source. 180, 200, 180, 100 calorie per gram is the calorific value of this waste. I don't know why throwing could have you seen. So we have to use the spectacle of a typical science student and look something. That's how we keep on talking about circular economy. But efforts from this young scientist has to be seen down the time. Then only we'll be able to reflect economy, which will become a very important, you can say, important role to make from Vikassheel to a Viksit. So now look at these are the calorific value, and at BRC we have made one model plant of 50 kg per hour. उससे energy निकाल के we are presently trying to use boiled water and all, and this model plant then later on will as a model plant for all the states, so that they can look at it. Maybe economics में थोड़ा बाद में बात करेंगे, because you look at the mobile भी तो पहले 15,000 20,000 का था, अभी तो means economics will come later. First of all, let us derive and develop the technology. I think वो तो हमारी एज में हुआ है. एक मोबाइल जब शुरू में था, इट वाज ए सेंटर ऑफ अट्रैक्शन, कोई लिया है तो ऑलमोस्ट उसके सामने कुछ एक घेरा बन जाता था. दिस फेलो इज वेरी इंपॉर्टेंट एंड ऑलमोस्ट ही विल नो विद अ प्राउड है मेरा भाई को लेके आया है, एंड नाउ वर इवन द मेड सर्वेंट और एवरीवन विल हैव द टिपिकल मोबाइल. सो टेक्नोलॉजी एंड वंस इट ड्रिवन ऑटोमेटिकली इकोनॉमिक्स विल कम इनटू पिक्चर. This is how the water getting polluted, and this may be a story of all the city or urban and near all the the effluents will be getting pumped without a serious look on the effluent management scheme. And effluent management scheme is nothing but a hybrid chemistry process. They may be reverse osmosis, they can be ion exchange, they can be chemical precipitation, they can be adsorbents. So this is what we are talking about offshoot applications when we developed the mask, which was being even the technology was given to different vendors, so that we need not be in the clutches of China, and China was whatever material which was getting pumped into India all was non-degradable. And an estimate was showing tons and tons of non-degradable waste will come, and that again, अगर वो धरती के अंदर जा landfill में, तो the soil will become infertile because excess of water will not be there at all. अरे कोई भी country अच्छा चीज क्यों देगा भाई वो India को? No, that means so we have to stand on our own feet if we have to run and win the race. So Indian development is a we made a transparent face mask also. वो एक अंदर filter है, वो filter को बाद में change करो and it becomes because वो बीच में crime rate बढ़ गया था. वो mask पहनने के बाद में वो सुरेश या रमेश से मालूम पड़ता नहीं था. And even the crime rate was also increased. So we developed what is called a transparent engineered valveless mask. Again, this mask was given to technology for the different vendors in the country, and maybe one in Delhi as well. This was given, and the work was appreciated by our Honorable Minister of Science and Technology, Nuclear Science. That is good. But maybe last couple of slides, वो जब तक गोरी चमड़ी का स्टैम्प लगता नहीं, जब तक मजा नहीं आता ना. So थोड़ा वो भी दिखाना पड़ेगा. So this is a gentleman from Japan. He visited and in fact he told I envied when he saw the facilities and found that radioactive waste is becoming wealth. So now earlier when he said that we have a collaboration means collaboration मतलब वो था पहले हम उनसे सामान खरीदेंगे and they were earning money and that time गोरी चमड़ी का स्टैम्प लगता नहीं, जब तक मजा नहीं. अरे collaboration क्या अब तो हमारा पैसा आ जा रहा है boss. This is collaboration from Japan. Let us come to one-to-one level. I तो मतलब we are proud asking now they are asking now collaboration from India to Japan. Collaboration मतलब वो था पहले हम उनसे सामान खरीदेंगे and they were earning money and that time गोरी चमड़ी का स्टैम्प लगता नहीं, जब तक मजा नहीं. अरे collaboration क्या अब तो हमारा पैसा आ जा रहा है boss. Let us come to one-to-one level. We are proud asking they are asking now collaboration मतलब वो था पहले हम उनसे सामान खरीदेंगे and they were earning money and that time अरे collaboration क्या अब तो हमारा पैसा आ जा रहा है boss. Let's come to one-to-one level. We are proud asking they are asking now we need your help in Japan. That means now they have started वो बदले से सूट नजर आते हैं अंदाज वो something like that. अभी now they are asking our help. So how time changes and now the future belongs to my young generation. I'm sure the day is not far away, but then we will see the fruits of our young scientists from maybe this university and other universities to joining all our premier institutes. तो premier institute कोई premier institute import नहीं करता है, वो तो हम जैसे इंडिया का ही भाग है. तो हम आप सभी प्रोडक्ट वहाँ के होते हैं, है ना? It represents mini India there. And then all of you when they go and excel, I am very sure whatever जो रास्ता अभी जो मंजिल हमने पकड़ी है, I am very sure this is not a destination, this is only a small intermediate station what we have got. We have to cover a long distance, but I am very sure the path is becoming brighter because we have the strength of these young generations with us, young scientists. All these are all almost a repetition of words that our technology and excellence in chemical sciences and all. But because we have been explaining, so I will just rush up with this. And of course, these are some of the results which sometimes when you remember, ऐसा भी था क्या? तो sometimes you don't believe yourself sometimes. So this was one of the proud moment when at least Mother Earth, मतलब जहाँ जन्मभूमि है. I remember when prize was given, then Honorable Chief Minister was telling, "Arey Kaushik ji, you have done sufficient for your Karmbhumi. Abhi Janmbhumi mein aiye and try to do something more." So this probably I am really thankful to Honorable Vice Chancellor that something has been done, and I could be and to share. So Jai Hind and Jai Bharat. So, the ring finger as an outreach program, I always mention this ring finger is the volume of radioactive waste which will be getting generated. If an Indian family maybe you 5 पकड़ लीजिए, 7 पकड़ लीजिए, whatever. If Indian family consumes all its electricity given from nuclear technology, in all of our spheres of life, lift में जा रहे हो, mall में जा रहे हो, कहीं भी, जब भी अगर आप electricity use कर रहे हो, throughout your life, maybe 80 years and all, then whatever is the waste getting converted, that volume will be small ringer. So I sum up by telling that nuclear technology is a nearly renewable source and will play an important role to minimize the carbon footprints in times to come. With this, this is what I got the two paper which in 2024. This one shows कि अपने जितने भी भारत के न्यूक्लियर पावर प्लांट्स हैं 20 years उनको पूरा हो चुका था. A good scientist team coming from even International Atomic Energy Agency Vienna, because again हम कभी भूलते नहीं. अरे हम बोलेंगे तो हो सकता है कि हमारे नागरिक थोड़ा उसको डाइजेस्ट करने में थोड़ा एक गोली चमड़ी का आ जाए तो थोड़ा उनको लगेगा नहीं भाई ठीक है करके, तो उनको भी टीम ने सम्मिलित किया. And then they found that 20 years of operation, the residual background radiation level was much less than, I repeat, much less than the cosmic dose we are getting from radionuclides. What in all of us, मालूम नहीं आप लोगों ने सोचा है कि नहीं कभी एक्सरे कराते हैं तो कितना रेडिएशन लगता होगा, और किसी डॉक्टर ने रेडिएशन नहीं बताया तो बोलेगा डॉक्टर कुछ आता है नहीं, एक्सरे तो करायो ना ससुरो, एक्सरे तो करायो ना. अरे वो डॉक्टर को जरूरत नहीं लगा होगा, लेकिन एक्सरे कराने में कितना रेडिएशन एक्सपोजर हो गया, दैट वी नेवर नो. But this shows that 20 years operation, and this particular paper again in 24 that shows that radiation level small amount, even it is used for your biological systems. So these are the two papers which definitely change the color of thought pattern at large. Because and हमारा कसूर नहीं है, because the first, as I told in beginning, the impact has gone so deep. Because the first use of an important discovery has gone for a destructive purpose, and that वो घाव थोड़ा गहरा था. Slowly we have to make sure that we show all those things, put our best efforts to see that no it was not, because this is because of the first use. With this I think I stop. Thank you so much for
बहुत धन्यवाद. हरियाणा विज्ञान रत्न अवार्डी हमारे प्रोफेसर चित्र जिन्होंने समस्त ज्ञान सबको दिया, और ये भी सत्य है कि विष्णु से गुरुत्वाकर्षण बल माना जाता है और नाभिकीय बल शिव से माना जाता है. उसी को ही आधुनिक रूप से सबके समक्ष प्रेषित किया. मैं हरियाणा के निजी विश्वविद्यालय के सभी शिक्षकों छात्रों की तरफ से आपका बहुत बहुत आभार. आइए कार्यक्रम में हम बढ़ते हैं और मैं आवाज दे रहा हूं प्रोफेसर विकास बेनीवाल जी को कि वो मंच पर आए और प्रोफेसर अमित हुसैन गुप्ता जी के बारे में, उनके कृतित्व, उनके व्यक्तित्व के बारे में हम सबको परिचित करें. प्रोफेसर विकास बेनीवाल जी.
Honorable Vice Chancellor Sir, Professor Chief Guest, Professor C.K. Kumar, C.P. Kaushik, Guest of Honor, Professor Gupta, Deans and Directors, Heads of various departments, faculty members, humanitarian. We have with us Professor Amital Sen Gupta, and I have a CV of Professor Amital Sen Gupta, and I am very delighted to share his contribution. Dr. Amital Sen Gupta received the MSc and PhD degree in physics from the University of Delhi in 1974 and 1980 respectively. His PhD work involved experimental and theoretical studies of traveling atmospheric disturbance using satellites. In 1979, he joins the Time Standard section of National Physical Laboratory, New Delhi. He superannuated from NPL in March 2015. As an acting director holding a position of outstanding scientist, he is presently an honorary distinguished professor of the Department of Space, ISRO, and is also associated with the North Cap University program as a distinguished research professor. He is a chair of Commission A of URSI and General Secretary of Indian Radio Science Society. Dr. Sen Gupta has expertise in the area of radio and atmospheric physics, electronics, atomic physics, and time and frequency standards. With over 4 decades of research experience, with major contributions include the development of India's first satellite-based standard time broadcast using domestic insert satellite in 1990s, and the design and development of India's first and one of the world's most accurate primary atomic clock known as cesium counter. He had initiated research and development on single-track YP, ion-based optical frequency standards at NPL, which his former group colleagues are carrying out at present. Dr. Sen Gupta was one of the youngest Indian scientists selected to participate in the first Indian Antarctic expedition in 1981-82. He subsequently participated in the second, that is 1982-83, and the eighth, 1988-89 Antarctic expedition. His work in Antarctica has been basically on radio noise studies and quantitative modeling studies of the high latitude D region using PLF phase measurements. He was selected to lead the 100-member team of 8th Indian Antarctic expedition in 1988-89. This was a very indigenous Indian research station method. All the tasks of expedition were carried out with great success, and the team of scientists were left behind for the first ever drinking at Metric. Dr. Sen Gupta is a fellow of National Academy of Science in India, fellow of Institute of Electronic and Telecom Engineers, India, fellow and former president of Meteorology Society of India, and senior member of IEEE USA and URSI Belgium. He was awarded the prestigious O.P. Basin Foundation Award for Science and Technology for the year 2002 for outstanding contribution in the field of electronics and information technology. With this word, I would like to invite Professor Amitav Sen Gupta to come on the stage and share his vast experience among us.
ना ना ये पावर बैंक लगा दो पावर बैंक से पावर बैंक
So good afternoon to all of you. And Sorry for that initial hiccup. I wish it had worked from my laptop. Then things would have been much easier. First of all, once again, thank you very much. It's a great honor to be invited to deliver the Science Day lecture. But before I deliver the lecture, let me just say that right in the introduction, Professor Sankesh, she said that the theme of this workshop, this Science Day today, is indigenous technology, innovation, and so on. And one of the parts of doing everything indigenously is to be able to speak your own language. So, if you like, I am a Bengali, but I speak good enough Hindi. So, if you like, I can deliver this talk in Hindi. But if not, well, but going in English will be faster. So if you are okay with English, I'll talk. But just to say that I can speak Hindi, if you like, I'll probably give bits and pieces of Hindi. That's one. And the second thing, I wanted to just tell all the youngsters here that we, the reason why we are celebrating Science Day is the discovery of Raman effect. And this gentleman, Sir C.V. Raman, is probably one of those that you have just seen in pictures, but I'm, amongst all of you, I'm old enough that it turns out that I've actually seen Professor C.V. Raman, from close distance. Just very briefly, the younger brother of Dr. C.V. Raman, Mr. C. Ramaswamy, he was the Director General of the India Meteorological Department, the weather forecasting people. My father used to work in the IMD, and I was born in the India Meteorological Department campus. And as a young boy, we used to roam around and so on. And one day, and I read in the school textbook, Sir Chandrasekhar Venkatraman got his Nobel Prize and all that. I was a very impressionable young boy, studying in class 8th or 9th, I can't remember. And one day my dad told me that, look, that gentleman out there is Sir C.V. Raman. He is visiting his younger brother. Believe me, it was such an exciting moment for us. I saw him from close distance. Unfortunately, we didn't have mobile phones, so otherwise I could have taken a selfie with him. So, but at least I have the picture very clearly still in my mind. So, anyway, coming to the talk, coming to today's talk, it's Exploring Antarctica, a journey to the White
थोड़ा सा कम कर दीजिए. हाँ, A Journey to the White Continent. Now, as was told in the introduction, I was a member, one of the youngest members of the first Indian expedition to Antarctica. So that was many years ago. That was about more than 40 years ago, 43 years ago. So many of you here, perhaps not born. So this is something that I feel very passionately about, one of those extremely exciting experiences. So I kind of get carried away and speak too much. So if at any time you think this story is getting too boring, you're not interested, please make some noise and, look disinterested. I'll get the message and I'll stop. If you don't, then I'll continue talking. Okay, so the way I've structured, this is just a storytelling. I'm not going to talk much about science and so on. This is just a little bit of a nice story about a continent. So I've structured it in this way. I will first talk about the continent as such. You have all heard about Antarctica, but perhaps some of the very interesting features of this very beautiful continent you're not aware of. So I'll spend some time talking what is Antarctica, what are its features. Then I'll talk, in the middle part of my talk, I will talk about the expeditions to the journey of Indians to Antarctica, how we went through the seas, spent a month and so on and so forth, etc. And finally, I will talk about the science in Antarctica. What science do we do in Antarctica and why is it interesting? So this is the way I've structured my talk. And if you at any given time think, most of you think that it's getting too long, too boring, you've already, been here since morning. So if you think it's disinteresting, please let me know and I'll stop, okay? So with that, so Antarctica is, unfortunately, I don't have a collar mic, otherwise I would have gone there. So Antarctica is a frozen land around the South Pole. It's also called the frozen continent. Why? And many of you wonder, where is Antarctica? So, this is India, this is where we are, and Antarctica is right here at the bottom. It's near the South Pole. So, it's a very large continent. It's a large island. It's a very large continent. It has an area of 14 million. The area is about 14 million square kilometers, but 14 million square kilometers doesn't tell you much. But let me just say that the size of the entire continent is the total area of India and China combined together. That's how large it is. It's 1.5 times the United States. That's how large this huge continent is. And about most of this continent is frozen. It's covered with a layer of ice. And about 90% of all ice in the world, all fresh water in the form of ice, is available in Antarctica. It's a continent which fluctuates in size as 2:1. In summer, the continent is about 14 million square kilometers. This is a satellite picture. And in winter, the sea all around it freezes, so the size becomes twice as much. So it's a fluctuating continent. It enjoys several superlative features, highest, most, coldest, etc. So what are those? It's the coldest. Naturally, it's something that all of you know. It's the coldest continent on Earth. The lowest temperature ever recorded on Earth, minus 93.2 degrees centigrade, was recorded in Antarctica. Now, and these are some of the places where the lowest temperatures have been recorded. Now, minus 93 degrees centigrade, I have not experienced it in my expedition. The worst we got was about minus 35 or minus 40, that's bad enough. But minus 93 is so cold that if you take a jug of boiling water and just toss it up, the water freezes before it hits the ground. That's how cold it is. It's the driest continent. That something doesn't make sense, kind of doesn't appeal to intuition, because you think with such a lot of ice, how can it be the driest? But it is indeed. There is hardly any precipitation in the interior of the continent. There are some parts of Antarctica that have had no rain or snow in the last 2 million years. It's the windiest continent. There are extremely strong winds all around the coastal areas in Antarctica. The highest wind speed, about 300 kilometers per hour, has been recorded in the coastal areas of Antarctica. I myself, in one of our expeditions, have experienced something like 200 kilometers per hour. 200 kilometers per hour is something, I cannot describe to you how terrible it is. You cannot just stand here, you have to hold on to something. It's extremely difficult. It's the highest continent. How is the highest continent? It turns out that the ice cover on Antarctica is so high that around the middle of the continent, around here, the ice layer is about 4.5 kilometers thick. So that makes the average height of the continent the highest in the world. It's the remotest continent. The nearest landmass, it's just an island, with the nearest landmass is the tip of the southern American continent. It's about 1,000 kilometers. All other continents are joined together by land, Asia, Europe, America, etc., etc. But this has the nearest continent, which is about 1,000 kilometers away. It's the emptiest continent. There is no native population. Nobody lives in Antarctica permanently. In summer, there are 44 permanent stations around the coastal regions of Antarctica, and 2 of them are Indian stations. We have a station here, Maitri, and we have a station somewhere here. I'll show you pictures of those stations. So there are 44 permanent stations, and out of those, 28 are populated in summer. And the total continent, the size of India and China together, it's such a huge landmass. There are only about 4,000 people that live in the whole continent in summer, and only about 1,000 people in that entire continent live in winter, right? It has some of the most beautiful views. It's something that you cannot capture in photographs. You have to actually see to believe it. It's some of those fascinating pictures that you get to see in Antarctica. Well, with a rider, that it has to be a good weather day. The weather has to be good. Okay, the Antarctic waters all around are extremely cold, and this creature called the krill, it's a shrimp-like creature, small jhinga machhi hota hai na, waisa. It's available in abundance, and the krill makes the bottom of, I'm not going to read through all this is a lot of description, but this creature has a lot of protein. About 15% of its body mass is protein, which can be harvested. This is found in such huge abundance that almost all the rest of the creatures, the penguins, the seals, the whales, everything, all of the higher forms, they eat krills for living. It turns out there's so much abundance of krills that if we could go and fish krills and bring them back and use them for our own food, that it would solve human beings' problem of protein, right? But it's still not economically feasible because it's very far away, right? I have a nice video. It's huge abundance. A little bit about the history ago, all the continents, were joined together in a large continent called the supercontinent or the Gondwana land. And gradually, after a little while, they started breaking apart, and they started breaking and floating away. Now you can start seeing the shape. This is the peninsular India, this is Europe, and this is North America, South America, Australia, etc. They started floating away, and gradually the Indian peninsula floated and hit the Eurasian plate, and the Himalayan mountains came up, and what remained was Antarctica here. So this is the history, geological history of formation of Antarctica. A little bit about the history of exploration. Again, because of shortage of time, I shall not go through the entire detail, but just to tell you that although the human civilization is very, very old, the first time any human being has ever gone to Antarctica is just about 250 years old. The first time, 1772, this gentleman, an Englishman, they went on a ship and went around the Antarctica, circumnavigation. And just about 200 years ago, people went and landed in Antarctica, went to the South Pole and so on. And the first time the Indians went to Antarctica was as recently as just about 43 years ago, so 1981, 82. And fortunately, I was one of the youngsters who have made it to Antarctica. Now, all other countries, India, America, Japan, Korea, etc., they belong to somebody. Who owns Antarctica? Does anybody know? Well, nobody owns Antarctica. Although 7 countries think they do. So, these are the 7 countries. They lay claims on piles of Antarctica. This claim is not contested by anybody, nor is it recognized by anybody. I mean, they think they claim parts of Antarctica. Nobody recognizes this claim. Nobody contests the claim too, right? So, the Antarctic Treaty was first signed by 12 countries in December 1959, and it sets Antarctica aside as a scientific preserve, establishes freedom of scientific investigation, and bans military activity on that continent, right? And as of 2016, as of today also, there are a little over 50 countries, including our own country, who are signatories to this international treaty called the Antarctic Treaty. And what are the terms and conditions of that Antarctic Treaty? The area is to be used for peaceful purposes only and no military activities, right? There should be freedom of scientific investigation and cooperation. There should be free exchange of information and personnel in cooperation with the United Nations. The treaty does not recognize, dispute, nor establish territorial sovereignty claims. 7 countries may feel happy in claiming part. Who cares, right? The treaty prohibits nuclear explosions. So unfortunately, Professor Kaushik will not be able to set up his nuclear reactors. Okay. The first time the Indians went to Antarctica, first expedition was led by this gentleman called Dr. S.Z. Qasim, Syed Zahoor Qasim. And I don't know if you can recognize who this was, the 21-member team. This is a terrible photograph. So that was me. I was just a 28 year old. I didn't have the a long time ago, and this mission, and unfortunately I'm not going to, because of shortage of time, I'm not going to go into details, but some of you who are probably roughly my age here will remember that this was a top secret mission called Operation Gangotri. So nobody in the world, we were selected for this expedition, and we were told not even to tell our own families, that we were going to Antarctica. This was one of those top secret mission, Operation Gangotri. So, but unfortunately, most of us, I come from Delhi, and we have not seen cold climates. I have not gone on sea. Before that, I have not even seen a ship before, so we had to be given training. So first training that was given to many of us was cold acclimatization. So we were ice acclimatized in the Himalayas. So in those days, we didn't have problems in Kashmir. So as civilians, we were trained in the areas of Kargil and Machoi glaciers. So today you cannot go to Kargil, thanks to this problem with Pakistan and terrorism and so on. So and then we use this small ship. I'm sorry, this is a terrible photograph. I'll show you better photographs later. This was a Norwegian icebreaker ship that we used to take to the expedition. This was a very small ship, about 50 meters long, but this was a nice icebreaker that we used in the first expedition. And how did we go to Antarctica? We started from Goa. You can see Goa here, and this is where we set up our station. So this was the route. This is roughly about 12,000 kilometers, and we went on the ship on the Indian Ocean, the Arabian Sea, Indian Ocean, Southern Indian Ocean, etc. It took us approximately 1 month to go to Antarctica, right? Now, initially, I'll show you some pictures on the way, right? So initially, when we went on the Arabian Sea, it was nice and quiet sea, and it was getting kind of a little boring, sunrise and sunset and flying fishes, etc., etc. But very beautiful pictures of sunset and sunrise. Now, you see that around the globe, you have a lot of continents near the equator in the northern hemisphere, etc. But in the southern hemisphere, this area between 40 degrees south and 50 degrees south, there's hardly any landmass. Now, what happens is, when you have such a lot of ocean and no landmass, the ocean water in these areas is highly turbulent because of weather systems that form, the cyclone systems that form. So this area is called the Roaring Forties. We have terrible cyclones that form in this area. And when your ship goes through this region, it has to pass this region to go to Antarctica. And when it goes through this region, what you have are you have sea waves. Just to give you a visualization, the height of this auditorium, you have waves that are this high that come and hit your ship, from the front, from the side, for just about 2 days or so, and it's a terrible feeling. So, and at that time, what happens to human beings is you get seasick. You vomit, you cannot stand up, you cannot eat. It's a terrible feeling. So many people also feel scared. So one of my friends came and asked me, "Yaar, तुम्हें डर नहीं लग रहा है? Swimming तो आती होगी?" मैं दिल्ली से हूँ, मुझे स्विमिंग नहीं आती है। वह स्विमिंग आने से भी कोई फायदा नहीं, पानी में अगर गिर गया तो हार्ट अटैक से वैसे ही मर जाऊंगा स्विमिंग। Because the water underneath is about 4 or 5 kilometers deep. वो स्विमिंग करके मैं कहाँ जाऊँगा? So anyway, so that's the Roaring Forties that we have. So anyway, this is a very long story. So we take special precautions to tie everything down properly. Otherwise, things go flying around. So, but afterward, all bad things come to an end. Finally, when you come to the 60 degrees south or so, all the turbulence, everything is gone, the sea is very quiet again, and you start seeing icebergs, floating ice. Icebergs, you have heard about them. And you also see these nice birds called wandering albatross. Albatross is the largest bird with the largest wingspan, about 12 feet or 13 feet across. It's about this big, wandering albatross. And these wandering albatrosses follow us for miles together. It's such a beautiful, and these birds are so beautiful, they don't flap their wings for flying, they just float around. So, and then when we go further down south, we start seeing floating ice packs. So this is the kind of thing that you see. You see the ship is going through and there are chunks of ice all around. These are called ice packs, floating ice, and nothing around for miles together, right? So, and after a while, this ice gets so thick that the ship cannot break through them. The ship has to stop. So that's when we take helicopters with us. That's when we take out our helicopters from the hold, from the storage area below the ship, and we start flying. We fly the helicopters and try to see if there is some opening in the ice pack, right? And when we find some, that's when we start. And it gets really so dense that such a huge ship has tremendous difficulty in going through. It's really hard. It moves very, very slowly. And far away, you can see the coast of the ice shelf. You can see in the far. And after some time, you start seeing large icebergs, The Antarctic icebergs are called flat-topped icebergs. They are large chunks of ice shelf that are broken away, right? And some of these can be really huge. They can be a couple of kilometers across. There's huge chunks of ice. And now remember, this iceberg that you are seeing here in the photograph, you all know that if you have a piece of ice on water, about 1/8 of it is above water, 7/8 is below water. So this is about 3 stories high. This is about this high. Imagine what would be underwater, right? So you start seeing some penguins. This is the first time you start seeing some penguins, trying to greet you. They're very curious. And then, as your ship goes through the icebergs, you start seeing the icebergs. Anyway, we also saw killer whales. Killer whales are killer whales. They're very dangerous. But believe me, they're so beautiful to look at. They're really beautiful to look at. They're shiny black with a nice fin at the back and pieces of white on 2 sides. They're very beautiful to look at. They may be dangerous, but I have not fallen into the sea. So this is the first time, this is a historic day, first time we landed, the Indian team landed in Antarctica, 9 January 1982. And this is the first team. We took a photograph after landing. That's usually what you do after you achieve your goal. And I don't know if you can recognize me, that's me. Anyway, so this was one of those exciting stories in those days. One of the magazines in those times, Professor Kaushik would remember, you are roughly my age. The Illustrated Weekly of India was one of those. It doesn't exist anymore. It carried on a front page a photograph of the Indian expedition. So then that's me again. We were trying to, there are penguins all around us. We were trying to feed the penguins, trying to make friends with them. But believe me, these penguins are so fussy they don't eat anything that is offered to them. They eat only krills and nothing else. So we tried giving them milk and eggs and whatever have you. But this guy is curious, but he doesn't accept anything from us. So there are two kinds of penguins in the area where, there are several kinds of penguins in entire Antarctica, but where we are, we had only two kinds of penguins. The shorter ones, the Adelie penguins, they're about this high, and the taller ones, they're about this tall. The emperor penguins. And they're very nice. I'll show you a nice video. These emperor penguins are really majestic. That's why they're called emperors. They go top, top, top. It's so beautiful to look at. So we also had seals, Weddell seals. So then we set up the first Indian base camp. We didn't have a permanent station. We set up our camp in tents. We had these army tents. And it is very cold outside. It's about minus 25 degrees or so. But we are adequately clothed. And we start living in tents, the first Indian base camp. And then we went around in these vehicles called the snow scooters. And you just see the landscape. There is no vegetation. There are no trees, no buildings, no human beings, nothing at all. It's just flat land of ice. Far away there are some hills, etc. But it's just flat white ice and nothing else. And then I went again in the second expedition 1 year later, and we tried to set up the first Indian building. We called it the Dakshin Gangotri station, but this was our first attempt. That's me again. And this building did not last very long. It lasted only 1 year. The next time when by the way, I'll show you a picture of that later on. And one of the interesting things that happens in Antarctica is that it's so far down in south that in summer in Antarctica, you have sun 24 hours. You can see the sun even at midnight. It's so weird. Normally we are all used to seeing the sun rise in the east, go overhead and go to the west, right? In Antarctica it happens in a very funny way. I mean, where we are. So during midnight the sun is there and it goes like this, it goes up and comes back. So it goes all around, it just goes up and down. And 24 hours you have daylight. It's so disorienting. You have to just look at your watch and decide when to go to sleep. So that's me standing at midnight, and this is where the sun is. So in the third expedition, 1 year later, 1983-84, I was not a part of the expedition. So the third expedition team, the Indians, we started building the regular permanent building, right? Construction of Dakshin Gangotri. And this is the final station which was built. This is a permanent Indian station which has provision for about 20 people living there throughout the year, and it's heated from inside, and you can do scientific research, etc., etc. So, by the way, just about a couple of months ago, celebrated the 40th year of Dakshin Gangotri. This station doesn't exist anymore. I'll show you what happened to this station. This is very interesting for the young physics students here. So, when in the first year, when we constructed this station, this, as you can see, is a two-storied building. You enter from the ground floor, and then you have stairs inside. You go to the top floor. On the top, you have a hatch for escaping gases, etc., etc., right? When I went again in the 8th expedition, that is 6 years later, 5 years later, this is what happened to Dakshin Gangotri station. you know, I don't know if you can make out, the entire station has gone under ice. And you can still see the hatch, this. So why does the station go inside the ice? See, any hot object placed on ice gradually melts the ice and it starts going in. You know, if you compress ice under pressure, its melting point goes down. You know, so it just melts. So the entire station gradually starts sinking, and it'll stop sinking when it is completely under ice. After that, it doesn't sink anymore. So what happens is, after some time, the entire station is just submerged in ice. So instead of getting into the station from the ground floor, now they get into the station from the hatch. You know, climb down into the station. So, and I'll show you, this is the expedition team, and you can see me here. I was the leader of the 8th expedition with the wintering team of the And when, in 1988, when I went for the 8th expedition, when we cleared the ice, you can still see the top, you can still see the roof of the two, so this is the, so we finally abandoned this station in 1989, not because the station was non-functional, it was working perfectly, but it was too risky. Inside the station, everything was just perfect, but we had to abandon the station because it was too risky. You know, should something happen inside the station, there is no way in which you can get the people out. It's completely submerged. So that's why we had to, with heavy heart, we had to just abandon the station in 1989. So that was the end of Dakshin Gangotri. And then what we did in 8th expedition, this is the ship that we went on. This is much larger. It is about 2.5 times larger than the ship that I showed you in the second expeditions, the Polar Circle, which was a very small ship. This called MV motor vehicle Thuleland. This is a Swedish ship which we used in the 8th Indian expedition. And then we wanted to set up a station not on ice shelf, but on permanent rock. Now, you remember in one of the early slides I had shown you that 98% of the continent is covered with ice. There are small bits and pieces of the station which are not covered with ice. And we found out one such place about 70 to 80 kilometers from where we landed. So this is a hill range called Shirmarkar Range. So this is where we set up our second permanent Indian station called Maitri. And we start constructing, I'm fast forwarding my story, otherwise it will last you the whole day. So we start constructing, and we have to carry all the building material, huge amount of building material for the construction about 80 kilometers from where the ship is anchored to where the station is by helicopters. So then we start building the station. The construction progresses briskly because everything has to be accomplished in about 3 months period. That's the summer time that we are there. And finally, the second Indian Antarctic station, Maitri, comes up in March 1989. So this is the building that we have. It is still, this is a permanent station that operates round the year, and we have a wintering team that stays back during the winter. Winter months are terrible because you have complete darkness. You know, like in summer you have 24 hours of sunlight, in winter you have 24 hours of darkness, so no sun at all. And it's extremely cold. So I'm really proud of, and this is another picture of this Maitri station from far away. You can see a small water lake which freezes in winter, but underneath is still water, because whenever a lake freezes, the water freezes only on top, underneath is water. water, because water at 4 degrees centigrade is heaviest, so it just settles down at the bottom. So all our fresh water requirements are from this lake, right? Now, this is me. That's the one in white. And with my wintering expedition team. Now, I just wanted to say that I'm extremely proud of this station, not just because it was constructed under my leadership 43 years ago, but primarily because this is one of those things, which was completely constructed indigenously. Everything about this station, way back in 1980s, was made in India, except two things. I'll tell you in a moment what those two things are. The first of all, the entire building structure, all these things were constructed by the DRDO in their R&D engineers in Pune. All these prefabricated walls, the base structures, and inside the generators were Kirloskar generators, and the heaters, the washing machines were Sumit washing machines. So those of you who are roughly my age would still remember Sumit washing machines and so on. Everything about the station was made in India. So I'm really extremely proud of this station. There were only two things which were not made in India, because unfortunately we don't make them in India. The first one was the satellite communication terminal. This satellite communication terminal, which was the lifeline, the telephone calls back home, was imported. There was another item which was imported, which was the machine that we use to degrade kitchen waste and so on, right? So, barring these two things, everything else was made in India. So this was the last time I took a picture on the last day of my stay in Antarctica in March 1989. So you can see this station has a main wing. It is two-story, and it has two side wings. This wing contains the kitchen and the bathroom, and the main wing contains the laboratories and the places for people to stay. And this wing has all the generators for generating electricity for the station. And these generators need a lot of fuel, a lot of oil. So all these oils are stored in barrels, oil barrels, which are very far from the station, because one of the most dangerous things in Antarctica, although there is a lot of ice, is there is no water. In case there is any fire, there is no way in which you are going to be able to extinguish it, right? So another interesting thing about this station is this structure here. This is a toilet. This is a toilet, and this is a special toilet because in Antarctica, because of extreme cold, nothing degrades. You leave some, organic matter, some human waste or something that puts some bacteria into the environment, and there is no way in which it is going to die. It's so cold there. When it gets very cold, it will probably freeze, but then when the temperature comes up again, it will just, start living again. So we have to be extremely careful about how we dispose of our waste, right? Okay, so I think that's a signal for me to stop because people are getting disinterested. Do you want me to stop? Okay. So in this toilet, in Antarctica, what we do is, all the human waste is collected in special containers and incinerated. It's burned. Unless you burn the waste, it's extremely difficult to dispose them off, because should they percolate down to the lake from where we get our water to drink, we are going to have it, right? And the reason why it is built separately from the main station in a particular direction is that in case it catches fire, you can cut it off from the main station, right? And this is another view of the Maitri station. This is not taken by me, this is taken by some of the later expedition recent picture. This station is still operational, about more than 35 years of existence. And one of our colleagues doing some air samplings, one of the things which Professor Kaushik showed was, well, he talked about are greenhouse gases. You know, one of the greenhouse gases is methane. And Antarctica, it's a very nice place to study all these greenhouse gases. You know why? That's because Antarctica is so remote, so far away from human civilization, human habitation, that if there is some change in the level of gases there, greenhouse gases, you know that it's truly a worldwide effect. So we have been, in all our Antarctic expeditions, we have been measuring all the greenhouse gases in the Antarctica. The methane, carbon monoxide, the nitrous oxides, and so on and so forth. So this is one of our colleagues making measurements. And then we do some radio communication studies. I'm not going to bore you with all that. Our geologists also fly helicopters and study the geology of the nearby rocks in Antarctica. Why is geology important in Antarctica? That's because, remember, I showed you the evolution of all the continents. I showed you initially they were all together in one continent, and when the Indian subcontinent broke off, you know, actually you can put it back as a jigsaw puzzle. The eastern part of it, the east coast of the Indian peninsula, was actually originally contiguous, was actually together with the eastern face, where we are in Antarctica. So, geologically, these two places should be similar. So whatever mines and minerals that we have in India should be available there too. So that's why study of geology becomes extremely important. Study of glaciology is also important, but again, I'm not going to bore you with all those details. And then later in 2012, we set up a third Indian station called Bharti. I've not been a part of these. This Bharti station is somewhere here. Our Maitri station, Dakshin Gangotri, these are places where we went in the first few expeditions. We still go here. And the third Indian station is somewhere here. It's quite far away. It's about 3,000 kilometers from these. This station is really nice and very modern, but like I said, it is not made in India. It's a completely bought out station from the Germans. It's a German station, but has fantastic amenities. Now, before I show you this picture, I just want to mention that I've shown you some nice and beautiful pictures of Antarctica, penguins going around and nice sunshine and so on and so forth. But please remember that the weather in Antarctica is so terrible that those kinds of nice pictures are available only on very few days. And when you have very few nice weather days, you click pictures, right? Most of the time the weather is so terrible, and sometimes it is really bad. You have what are known as snowstorms or blizzards. I'll just show you a short video of blizzard. And it's not taken by me, I picked it up from the internet. Wind speeds of 200 kilometers per hour. And you cannot see from here to there. It's completely white out. You cannot see. If you are out of your station, just you go only less than 10 yards away, you cannot come back to the station. It's so terrible. So such a kind of blizzards that you encounter every night. So the other thing that I mentioned is fire hazard. If there is a lot of, it's such an ironical situation that you have a lot of ice all around you, but you don't have a drop of water with which you can extinguish your fire. We had, during our construction, we had one such fire accident in one of the incinerated toilets. Fortunately, that toilet was far away from the station, so it didn't cause any major damage, but we saw it go up in flames. So there are other accidents also, but let me just skip. We have had a helicopter accident in the third expedition. I was not a part of it, but fortunately nobody died here. But we, a couple of our colleagues came very close to dying. You know why? The water in Antarctica, in surrounding the oceans in Antarctica, is not 0 degrees. You know, the water doesn't freeze at 0 degrees because it has a lot of salt in it. If you have salty water, the freezing point is depressed. So the water temperature in the surrounding water is about -2 degrees centigrade, and it's still water. And if you put somebody, and remember my friend was asking me if I knew swim, you know, so it wouldn't help. You know, if you fall down in that water, it takes you only about 2 minutes or 3 minutes to kill. It's so cold, right? So we almost lost a few of our colleagues in this helicopter accident. They came to very close to death, but they somehow survived, right? And another very dangerous thing in Antarctica is, I mean, it's probably the same in Siachen or other places also, is what is known as carbon monoxide poisoning. When you have extremely cold climate, you know, you try to cover yourself inside the tent, and if you have, you know, some fire going, even a candle, when it burns, it emits carbon dioxide and a little bit of carbon monoxide. And carbon monoxide is a silent killer. So these guys, some of our geologists in the 10th expedition, it was very cold, so they took their petrol generator inside the tent, turned it on, and went to sleep. You know, so gradually the carbon monoxide levels grew, and they just died in their sleep. So we lost 2 very courageous geologists in this expedition. So what I'm trying to say is Antarctica is all very nice and nice pictures, etc., but it's not all fun and games. You know, it's extremely dangerous and at times can be quite disastrous too. So we have to be extremely, extremely careful. Why is science in Antarctica interesting? It's the most untouched and undisturbed region on the planet, being remote, isolated, and frozen all year. Science in Antarctica offers many advantages over anywhere else on Earth. For example, it has the cleanest air in the world, allowing air quality monitoring with a reliable baseline. It's the darkest place on Earth. In winter, there is no sunlight. Ideal setting for astronomical research. And I talked about the krill, those shrimp-like creatures. It's the bottom of the food chain, allows scientists to better understand environmental impacts on humans. And it has no borders, allowing research findings to be freely available to everyone. Also, many projects are internationally coordinated and supported without any home turf issues. What are some the Indian scientists studying in Antarctica? I'll just give you the headings because it's already late and I don't want to take more of your time. Meteorology, global climate change, that's one of the main things that we study in Antarctica. They say that the Indian monsoon has a direct connection with the global warming in Antarctica. So it's very important to study meteorology in Antarctica, particularly from the perspective of global climate change. I already talked about geology and glaciology. Glaciology is the study of the ice cover, right? Earth sciences, astronomy and astrophysics. Aeronomy, most of you don't understand, is the study of the upper atmosphere for ionized atmosphere, ionosphere, radio communications, that's what I did, marine biology, and human biology under stress. So these are some of the things, and over the years, a few more things have gotten added to this. So that's about all. Thank you very much. See, in the initial years, when we went to Antarctica about 40 years ago, last time I went was 1989, which is again a long time ago. But many of the youngsters here perhaps will get motivated by my describing this to you. Perhaps you also want to one day go to Antarctica. Now, believe me, it's today much easier to go to Antarctica than it was 40 years ago, because opportunities are much more today than at that time. And but then again, I don't want to make myself out to be a superhuman being. Many people have asked me, hey, by the way, how did you get selected for Antarctic expedition? I mean, there was nothing superhuman about me. I was just a young experimental physicist, and they were looking for one. There were probably hundreds of others going around. So I just happened to be at the right place at the right time. So that's how I got selected, right? So, but then many of you who are, kind of enamored by these nice pictures, the nice climates, and such exciting prospects and prospects of adventure will probably, take it up in the future and study some interesting science in Antarctica. Thank you again. You don't allow questions, so I guess if somebody has a question. No, that's okay. I think we are already behind schedule. If somebody has a question, I'll be happy to. No, I think that's okay.
थैंक यू सो वेरी मच सर, बहुत बहुत आभार आपका। पूर्ण रूप से अंटार्कटिका की सफर जो है आपने करवाया है हमें, आपका मैं बहुत बहुत आभार करता हूँ। और विभिन्न प्रतियोगिताएं इस क्रम में रही इस पूरे दिन, जिसमें स्कूल, कॉलेज और यूनिवर्सिटी का स्तर रहा, और 6 प्रतियोगिताओं का हमने आयोजन किया, जिसमें पेंटिंग, स्पीच, क्विज, वर्किंग मॉडल, आइडिया ऑफ इनोवेशन, पोस्टर प्रेजेंटेशन, बेस्ट आउट ऑफ वेस्ट, ये प्रतियोगिताएं रही। कल ये प्रतियोगिता में थी, आज उन सभी पुरस्कृत विद्यार्थियों को पुरस्कार दिया जाएगा। बड़े करीने से और बड़े सलीके से हमने जो है पुस्तकें रखी हैं जो दी जाएंगी। मैं निवेदन करता हूँ माननीय कुलपति जी से कि वो मंच पर आ जाएं। हमारे मुख्य अतिथि प्रोफेसर चेतन प्रकाश कौशिक जी से निवेदन है कि वो मंच पर आ जाएं। प्रोफेसर अमित वसीम जी से निवेदन है कि वो मंच पर आ जाएं, ताकि हम उन विजयी विद्यार्थियों को पुरस्कृत कर सकें जिन्होंने विभिन्न प्रतियोगिताओं में प्रतिभाग किया और अवार्ड जीते हैं। आइए, सबसे पहले जो मैं आवाज दे रहा हूं, पेंटिंग रिजल्ट का अनाउंसमेंट कर रहा हूं स्कूल स्तर पर। इस क्रम में हमारे साथ सभी प्रबंधन समिति के सदस्य हमारे साथ जुड़े और कुल सचिव सर भी हमारे इस पुरस्कार वितरण में हमारे साथ जुड़ गए। रजिस्ट्रार साहब, प्रोफेसर नीरम संगवान जी से निवेदन है कि मंच पर आ जाए। हालांकि मेरी योजना ये थी कि आगे आगे एक कुछ जोड़ते चले जाएं, कुछ ना कुछ एक ज्वेल जो है वो हमारे साथ जुड़ता रहे, लेकिन मैं चाहता हूँ कि सभी एक साथ आ जाएं। प्रोफेसर सुनीता श्रीवास्तव जी से भी निवेदन है कि मंच पर आ जाए। आइए, पेंटिंग प्रतियोगिता के रिजल्ट बोल रहा हूं। तीसरा स्थान प्राप्त किया है आरपीएस महेंद्रगढ़ के अरुण कुमार ने। जोरदार तालियों के बीच में विद्यार्थी तुरंत दौड़ते हुए मंच पर आ जाएं। दूसरा स्थान राव प्रहलाद सिंह सीनियर सेकेंडरी स्कूल। वेदांशी आरपीएस महेंद्रगढ़। वेदांशी आरपीएस महेंद्रगढ़। योगिता चोकर राव प्रहलाद सिंह सीनियर सेकेंडरी स्कूल महेंद्रगढ़, द्वितीय स्थान। और पहला स्थान सपना मोंटेसरी कन्वेंट सीनियर सेकेंडरी स्कूल सदनारी। दौड़ते हुए मंच पर आ जाएं, उनके अध्यापक भी इस क्रम में हमारे साथ जुड़ जाएं। तीसरा स्थान वेदांशी, दूसरा स्थान योगिता चौकर और पहला स्थान सपना। कॉलेज और यूनिवर्सिटी स्तर पर पेंटिंग कंपटीशन में तीसरा स्थान प्रियंका, आरपीएस डिग्री कॉलेज बलाना महेंद्रगढ़। प्रियंका तीसरा स्थान। प्रियंका कॉलेज स्तर पर तीसरा स्थान वर्षा यदुवंशी डिग्री कॉलेज और पहला स्थान निधि यदुवंशी डिग्री कॉलेज। जल्दी से मंच पर आ जाएं और इनके शिक्षक अगर सभागार में उपस्थित हैं तो वे भी मंच पर आए। तीसरा स्थान प्रियंका, दूसरा स्थान वर्षा और पहला स्थान निधि। प्रियंका आरपीएस डिग्री कॉलेज से हैं, वर्षा यदुवंशी डिग्री कॉलेज से हैं, निधि उन्हें यदुवंशी डिग्री कॉलेज। केंद्रीय विश्वविद्यालय की भी टीम रही जिन्होंने अपनी पेंटिंग प्रतियोगिता में प्रतिभाग किया। तीसरा स्थान नरेंद्र, दूसरा स्थान संस्कार केसरी और पहला स्थान गायत्री पानी।
अगली कैटेगरी है स्पीच कंपटीशन स्कूल लेवल पर। थर्ड प्राइज गोज टू अर्पित फ्रॉम प्रताप सिंह मेमोरियल सीनियर सेकेंडरी स्कूल। सेकंड गोज टू रिद्धि फ्रॉम जीपीएस महेंद्रगढ़ एंड द फर्स्ट प्राइज गोज टू प्रेरणा यादव फ्रॉम आरपीएस महेंद्रगढ़। आप सभी जिन जिनको अवार्ड मिला है प्लीज स्टेज पर आ जाइए। अर्पित थर्ड प्राइज, रिद्धि सेकंड एंड प्रेरणा फर्स्ट। बहुत बहुत बधाइयाँ आप सबको। नेक्स्ट स्पीच कंपटीशन में कॉलेज कैटेगरी। थर्ड प्राइज गोज टू रोशन पोद्दार फ्रॉम सीयूएच, रोहन पोद्दार फ्रॉम सीयूएच। सेकंड गोज टू संगीता फ्रॉम आदर्श महिला महाविद्यालय भिवानी एंड फर्स्ट प्राइज गोज टू सानंद त्रिपाठी फ्रॉम सीयूएच।
अगली कैटेगरी है क्विज कंपटीशन, प्रश्नोत्तरी प्रतियोगिता। कॉलेज स्तर पर थर्ड प्राइज जो है वो एकता और सपना को मिला है यदुवंशी डिग्री कॉलेज से। दूसरा स्थान आरजू सैनी रिद्धि अग्रवाल केंद्रीय विश्वविद्यालय हरियाणा और पहला ऋतिक त्यागी प्रशांत कुमार केंद्रीय विश्वविद्यालय हरियाणा। जितनी जोरदार आप ताली बजाएंगे, अगली बार जब आपको पुरस्कार मिलेगा तो आपके अवसर पर भी ऐसी ही तालियां बजेंगी। कॉलेज स्तर पर तीसरा एकता सपना यदुवंशी डिग्री कॉलेज, दूसरा आरजू सैनी रिद्धि अग्रवाल केंद्रीय विश्वविद्यालय हरियाणा और पहला स्थान ऋतिक त्यागी प्रशांत कुमार केंद्रीय विश्वविद्यालय हरियाणा। आप सभी एक साथ आ जाएं, समय का थोड़ा सा अभाव है, हम जल्दी जल्दी आप सबको पुरस्कृत करना चाह रहे हैं। पहला स्थान, दूसरा स्थान और तीसरा स्थान क्विज कंपटीशन। स्कूल स्तर पर तीसरा पुरस्कार पंकज कुमार और वंशिका प्रताप सिंह मेमोरियल स्कूल से। दूसरा स्थान मुकुल यादव अनुवीर सिसोदिया डीपीएस महेंद्रगढ़ से और पहला स्थान सृष्टि गोयल मुस्कान हैप्पी एवरग्रीन सीनियर सेकेंडरी स्कूल। ताली बजा दीजिए।
अगली कैटेगरी है वर्किंग मॉडल्स की, जो साइंस एग्जीबिशंस में लगेंगे। वर्किंग मॉडल में फर्स्ट है यूनिवर्सिटी लेवल पर, थर्ड प्राइज मिला है वर्किंग मॉडल कैटेगरी में थर्ड प्राइज गोज टू फर्स्ट टीम है, जॉइंट मिला है, टाई अप है दोनों टीम के बीच में। एक टीम है जिसमें है जतिन कुमार, विदिका, प्रीति कुमारी, नविता। दूसरी टीम है जिसमें है खुशी, संजय, पायल और विमति। ये दोनों टीम सेंट्रल यूनिवर्सिटी ऑफ हरियाणा की है। दूसरा पुरस्कार जाता है कृति भारद्वाज और दामिनी को, जो है आदर्श महिला विद्यालय से, महाविद्यालय से। और पहला पुरस्कार जाता है सेंट्रल यूनिवर्सिटी ऑफ हरियाणा को, गौरव शर्मा, निकिता और संदीप। हर एक टीम एक एक करके स्टेज पर आएंगे और अपना अवार्ड लेंगे। आप चाहे तो स्टेज से पहले नीचे की ओर आप खड़े रह सकते हैं और जैसे ही आपका नाम बुलाया जाए आप पुरस्कार के लिए आ जाएंगे।
एक एक टीम करके हम मंच पर आएंगे। थर्ड प्राइज केंद्रीय विश्वविद्यालय हरियाणा की 2 टीम है। अभी सेकंड के लिए आ जाइए। आदर्श महिला महाविद्यालय, नीचे बैठ जाओ। अभी आप सभी से आग्रह रहेगा, विद्यार्थी इधर से आएंगे, इस हाथ से। स्कूल स्तर पर जल्दी बैठे आप।
चार लोगों ने रजिस्टर किया था बट बैक एंड हमारी पूरी टीम काम कर रही है।
स्कूल स्तर पर वर्किंग मॉडल को की घोषणा कर रहा हूं। थर्ड प्राइज आरपीएस महेंद्रगढ़, दामिनी और कृति, इन्हें नहीं मिला था, ये आप ले लें। आदर्श महिला महाविद्यालय से गौरव शर्मा, निकिता और संदीप। जी, थर्ड प्राइज के विद्यार्थी हैं ये आरपीएस महेंद्रगढ़ से मितुल शर्मा, अनुज और तनिष्क और शिवम। आरपीएस महेंद्रगढ़ की टीम तीसरा प्राइज इन्होंने जीता है वर्किंग मॉडल से। आपके समक्ष है, जोरदार तालियां बजाइए। उधर से उतर जाइए। दूसरा आरपीएस महेंद्रगढ़, उन्हें सेकंड प्राइज मिला है सिद्धांत, ध्रुव, प्रत्युष और ईशु कौशिक। आरपीएस महेंद्रगढ़ वर्किंग मॉडल्स में द्वितीय स्थान। टीम आपके समक्ष सिद्धांत, ध्रुव, प्रत्युष, ईशु कौशिक। और पहला स्थान आपकी तालियों के बीच ओपी जिंदल स्कूल हिसार, देव जानवर, मानस गोयल, अमन और गुणमय। टीम आपके समक्ष पहला स्थान इन विद्यार्थियों ने अर्जित किया। ओपी जिंदल स्कूल हिसार के ये छात्र, स्कूल के प्रबंधन को बहुत शुभकामनाएं, वहां के प्रिंसिपल साहब को शुभकामनाएं और जो शिक्षक आए हैं उनको भी शुभकामनाएं। पहला स्थान, जोरदार तालियां देवी और सभी में। आइडिया ऑफ इनोवेशन पोस्टर प्रेजेंटेशन यूनिवर्सिटी लेवल पर तीसरा स्थान केंद्रीय विश्वविद्यालय हरियाणा की दो टीम हैं। नाम ले रहा हूं। पहली टीम अमन, अमर नारायण, स्टेंजी, हर्ष सक्सेना, प्रशंसा सोनी। टीम आ जाए ऊपर। आइडिया ऑफ इनोवेशन पोस्टर प्रेजेंटेशन तीसरा स्थान जी दूसरी टीम का नाम ले रहा हूं, सलोनी, दिव्या और निविता यादव। सलोनी, दिव्या कुमारी, निविता यादव, अगर है तो मंच पर आ जाएं। द्वितीय स्थान योग विभाग की टीम, योग विभाग की टीम सेंट्रल यूनिवर्सिटी ऑफ हरियाणा दूसरा स्थान प्राप्त किया है यूनिवर्सिटी और कॉलेज स्तर पर। टीम जल्दी से स्टेज पर आ जाए। सलोनी, दिव्या कुमारी, निविता यादव सेकंड। मैं निवेदन करूंगा थोड़ा सा जल्दी आए आप। सेकंड है योग विभाग की टीम केंद्रीय विश्वविद्यालय हरियाणा। आइए आइए जल्दी आए। इस कार्यक्रम के बाद आपके लिए रिफ्रेशमेंट की भी प्रबंधन है, आप कृपया वो जरूर अपना लेकर जाएंगे। ये आईडी ऑफ इनोवेशन पोस्टर प्रेजेंटेशन की सेकंड टीम है जिसने द्वितीय स्थान हासिल किया है। योग विभाग की पूरी टीम, बहुत बहुत बधाई योग विभाग के शिक्षकों को, विद्यार्थियों को। और पहला स्थान इस क्रम में केंद्रीय विश्वविद्यालय हरियाणा की टीम, जिसमें बादल, महाकैलकर, पवन कुमार, मुकेश और प्रगति सिंह। अभी जो आपके समक्ष है ये तृतीय स्थान हासिल किया सलोनी, दिव्या कुमारी और निविता यादव ने। अब पहला स्थान केंद्रीय विश्वविद्यालय हरियाणा की टीम, बादल, पवन, मुकेश एंड प्रगति। आइए जल्दी आइए। स्कूल कैडर में इनोवेशन पोस्टर मेकिंग थर्ड प्राइज बीआरएस सीनियर सेकेंडरी स्कूल सेलम, महक, सिमरन, दिव्यांशी और साहिब, अगर हैं तो मुझ पर तुरंत आ जाएं। दूसरा स्थान थर्ड प्राइज बीआरएस सीनियर सेकेंडरी स्कूल सेलन, साहिल ने प्राप्त किया है, अगर है तो आ जाएं। द्वितीय स्थान टाई अप रहा है डीपीएस अक्षिता और एसडी सीनियर सेकेंडरी ककराला से महक, सिमरन, दिव्यांशी ने। साहिल नहीं है, उनके शिक्षक हैं। दूसरा स्थान डीपीएस अक्षिता और एसडी सीनियर सेकेंडरी स्कूल ककराला से महक, सिमरन और दिव्यांशी। तीनों विद्यार्थी आपके समक्ष एसडी सीनियर सेकेंडरी स्कूल की छात्राएं महक, सिमरन, दिव्यांशी। शिक्षकों को बहुत बहुत बधाई। और डीपीएस से जो टाई हुआ था सेकंड के लिए, अक्षय आपके समक्ष डीपीएस स्कूल। पहला स्थान डीपीएस स्कूल जिज्ञासा और मानवी, अगर हैं तो आ जाएं। शिक्षक हैं तो वो भी आ सकते हैं। बेस्ट आउट ऑफ वेस्ट यूनिवर्सिटी लेवल पर सीएच की टीम पहले स्थान पर रही, श्री प्रणाम चटर्जी यूनिवर्सिटी लेवल पर। चलिए स्कूल लेवल की अनाउंसमेंट कर रहा हूं। बीआर आदर्श सीनियर सेकेंडरी स्कूल, दिव्या और पूजा ये तृतीय स्थान इन्होंने लिया है। आ जाए। बीआर आदर्श सीनियर सेकेंडरी स्कूल सेहलत और पूजा तृतीय स्थान। कैटेगरी है बेस्ट आउट ऑफ वेस्ट और कैडर है स्कूल आपके समक्ष तृतीय स्थान प्राप्त करने वाली दोनों छात्राएं। दूसरा स्थान डीपीएस महेंद्रगढ़, नव्या यादव, तेजस यादव। अगर हैं तो मंच पर आ जाएं। और पहला स्थान नव्या यादव, तेजस यादव। नव्या यादव, तेजल यादव, डीपीएस महेंद्रगढ़, इन्होंने द्वितीय स्थान हासिल किया। स्कूल प्रबंधन और शिक्षकों को बहुत बहुत बधाई, शुभकामनाएं। और पहला स्थान आरपीएस महेंद्रगढ़, आकांक्षा, जयंतवर और सृष्टि यादव। मयंक वही विद्यार्थी जो करोड़पति बना है। करोड़पति विद्यार्थी आपके समक्ष देवी सज्जनों जोरदार तालियां बजाइए। आरपीएस स्कूल से बहुत बहुत बधाई शिक्षकों को, प्रबंधकों और प्रिंसिपल साहब को। यूनिवर्सिटी लेवल पर तृतीय स्थान केंद्रीय विश्वविद्यालय हरियाणा, श्री प्रणाम चटर्जी मंच पर आ जाएं। दूसरा स्थान श्रेयांशु, विशाल, विवेक। दूसरा स्थान श्रेयांशु, विशाल और विवेक। केंद्रीय विश्वविद्यालय की टीम है बी वॉक की आपके समक्ष अवार्ड लेते हुए और शिक्षक के साथ जुड़ गए। जब विद्यार्थी को पुरस्कार मिलता है तो शिक्षक स्वयं पुरस्कृत हो जाता है। पुणे केंद्रीय विश्वविद्यालय हरियाणा की टीम मुकेश, प्रगति, पवन और बादल के साथ पहला स्थान मुकेश, प्रगति, पवन और बादल। पवन भी है, बादल भी है, दोनों और प्रगति भी है। आइए जी, बहुत बहुत धन्यवाद। और हरीश जी को आमंत्रित कर रहा हूं वोट ऑफ थैंक्स के लिए। प्रोफेसर हरीश, आपसे इन सभी से आग्रह रहेगा पेंटिंग में एक संस्कार नाम का विद्यार्थी रह गया था, सर उसे अवार्ड कर दीजिए क्योंकि वो आ नहीं सका समय पर। रिफ्रेशमेंट की व्यवस्था आप सबके लिए रहेगी, ठीक, आप सभी उसके लिए बने रहें, बगैर रिफ्रेशमेंट लिए ना जाएं, ऐसा विनम्र आग्रह आपसे रहेगा। और इस हाथ पर जब आप बाहर निकले इस द्वार से तो बाहर इसकी व्यवस्था की गई।
Arrangement for the refreshment is from the backside gate. The student take note of this. So a very good afternoon to all of you. Respected Chief Guest, Professor C.P. Kaushik ji, Guest of Honor, Professor Amita Singh Gupta ji, esteemed Chief Patron, Professor Pankaj Kumar ji, distinguished dignitaries, Dean, HOD, TIC, faculty member, non-teaching staff, students, volunteers, and members of the media team. I stand before you today with a heart full of gratitude and immense joy as we come together to extend our heartful thanks on the occasion of National Science Day 2024. Celebrated with great enthusiasm, intellectual and passionate feeling at the Central University of Haryana, Mahendragarh. First and foremost, I express our deepest gratitude to Professor C.P. Kaushik ji, Chief Guest of the today function, for gracing us with his presence and sharing his invaluable insights. Your vast experience and knowledge in the field of nuclear science have enlightened us with inspired everyone present there. A special thanks to Professor Amita Singh Gupta ji, our esteemed guest of honor from NPL Delhi, for adding to the intellectual richness on this occasion. Your presence is added prestige to our celebration of National Science Day. We are honored to have Professor Pankaj Kumar ji as the chief patron of this event. Your guidance and support have been instrumental in making this celebration a grand success. We appreciate your commitment to fostering scientific spirit and innovation among faculty members and the students. I extend my sincere thanks to the convener, Professor Amit Kumar ji and Professor Ramesh Kumar myself, organizing secretary, Professor Vikas Benwal, Professor Kanti Prakash Sharma ji, and advisory committee, especially Professor Sunita Srivastava Madam ji and Professor Rajesh Gupta ji, for their meticulous planning and execution, ensuring that every aspect of this event unfolded seamlessly. Your dedication and hard work have not gone unnoticed to everyone. A heartful gratitude goes out to the convener of various committees, Dean, HOD, judges of different events, faculty members, non-teaching staff who have worked tirelessly behind the scene to make this event a resounding success. Your commitment to the cause of science education is commendable. To the students who actively participated, volunteered, and contributed to the success of National Science Day, your enthusiasm and passion for science are truly inspiring. It is through our curiosity and dedication that flame of scientific inquiry will continue to burn brightly. We extend our thanks to the media person, print and electronic media, who have covered this event, helping to spread the message of importance of science and research to a broader audience. In conclusion, I want to express my gratitude to everyone who played a role, big or small, in making National Science Day 2024 a memorable and enlightening experience. Together we celebrate the spirit of science and innovation, looking forward to a future where scientific advancement led us to new
अभी देखिए कार्यक्रम समाप्त नहीं हुआ, अभी वोट ऑफ थैंक्स हुआ, आप सब बैठिए, बैठिए बैठिए, 2 मिनट का कार्यक्रम हो रहा है। मुझे लगता है कि जो शुरुआत में आए हैं उनको नेशनल एंथम के बाद में नहीं उठना चाहिए ना, उससे पहले नहीं उठना चाहिए, उसके बाद में आप लोग बैठे, ठीक है, उसके बाद निकलेंगे, आप लोग बैठे सभी, स्थान ग्रहण करें। इधर से भी निवेदन है, आप अपना अपना स्थान ग्रहण करें। जो अनाउंसमेंट और है, ट्रेजर हंट के विनर्स